Is that she studies in high school and she would like to know if you recommend her to study astronomy. Pregunta que si es recomendable estudiar astronomía.
I am a little biased, but I think yes. I love it. It's the universe is so interesting and there's a lot to learn on Earth, but there's so much out there.
Okay.
And I like to study that. So
Okay.
yes.
Thank you. Dice que sí te recomienda estudiar astronomía, que el mundo tiene muchísimos campos de estudio, sin embargo que la astronomía, o sea, el espacio es algo que tiene que ser estudiado, entonces que sí es algo muy interesante y puedes aprender muchas cosas. ¿Alguna otra pregunta? Okay.
Thank you.
Okay, you're welcome.
Bye.
Bye.
¿Cómo te llamas? He's Leo, Andrea.
Hi, Leo. Hola.
Hola. ¿Por qué le quieres preguntar? He asked, how does the black holes are created? How are the black holes created?
So the question is, how are black holes created? The short answer is stars explode when they die. So when a star dies, it goes boom.
Ok, cuando una estrella muere, explota. Entonces chocan y la misma energía y gravedad que se genera provoca un agujero negro que absorbe más energía.
¿A dónde lleva las agujeros?
Okay, and where do the black holes go?
Well, they just stay. Oh, so the question is, where do the black holes go? That's a good question. They kind of just stay where the star was. And you usually find black holes, like really big ones, at the center of galaxies. So at the center of the Milky Way galaxy, there's a black hole.
Ok, dice que donde estaban las estrellas antes de explotar, ahí se quedan los agujeros negros, pero se siguen expandiendo. Entonces las galaxias tienen diferentes como agujeros negros que van como creciendo eventualmente por lo mismo que van absorbiendo. ¿Alguna pregunta? Ok, muchas, thank you very much. Claro, ¿cómo te llamas? Hi, Andrea, she's Carla.
Hi, Carla.
Hi. Es que escuché algo así como de que Júpiter no orbita realmente alrededor del Sol.
Okay. ¿Quieres preguntarle?
No.
Okay.
No.
She asked, well, she mentioned that she heard that Jupiter doesn't turn around el mismo.
Que el Júpiter no orbita el Sol.
Okay. That Jupiter doesn't Jupiter
doesn't orbitate around the sun.
Yeah, right. That he doesn't orbitate, like the Jupiter doesn't orbitate around the sun. Have you heard something about it?
I've heard that Jupiter does rotate around the sun.
Era como que se orbitaban, o sea, como que la gravedad era tan fuerte en Júpiter que como que se orbitaban a sí mismos, algo así.
Okay, well, what she mentions is that she heard that the gravity is so strong that Jupiter and the sun like interact due to gravity, like each other.
Right.
Find each other.
Yeah. No, yeah. So we call that. So you're right. It's orbiting what we call the center of mass of the sun and Jupiter. And so if it's kind of like the average. And that's true for Earth too. It's just Earth is so small that the center of mass is in the middle of the sun. So for that system.
Okay. Lo que entendí, en teoría sí, o sea, sí tienen gravedades fuertes y por lo tanto sí orbitan como entre ambos, pero realmente Júpiter sí orbita alrededor del Sol.
Ok. Entonces, o sea, es que no entendí, o sea, el centro de masa es más pequeño, por eso sí orbita el Sol. Pero
por eso Júpiter
orbita el Sol.
Y no el Sol.
Pero ¿cuál es la otra diferencia? O sea, ¿en qué sí se parece?
O sea, ¿cómo?
Es que no entendí lo primero.
Ok, sí hay una gravedad entre ambos, pero la masa de Júpiter es más pequeña que la del Sol. Entonces es
el sol le gana con su...
Ah, ok. Bueno, entonces explicaron mal ese video que vi. Yo dije, mejor la pregunta que quise saber.
Sí, claro.
Va.
Thank you very much, Andrea.
Thank you. Bye.
¿Alguien más quiere preguntar?
¿Nada pasado?
No,
Pues una vez.
yo ya pasé, ya pasé. Aquí tengo.
Hello.
Igual, sí, posiblemente. ¿Cuál es? Rodrigo.
Well, our new guy is Rodrigo.
Hola, ¿cómo está?
Bien, gracias. Excuse me, guys. Is there any way to know the songs? Well, ay, Dios mío.
En español.
The age of the sun.
Oh, there is. Yes, the sun is 4.5 billion years old,
Okay.
and it's
Yeah,
about
that-
halfway through its life.
Okay.
And you can tell based on how bright it is, what kind of elements, or what kind of atoms are in the sun, and yeah, so yep, so 4.5 billion years old.
Okay, thank you.
You're welcome.
Gracias.
Hi, I came back to ask you about your work in Orizaba.
Oh yeah, so it's an experiment called the High Altitude Water Cherenkov Observatory, or HAWK.
I think that you have a lot of tanks, water tanks.
That's
Am I right?
Yeah, we have 300.
Okay. Are you working there with neutrinos?
We work with a particle called gamma rays, not neutrinos.
Could you repeat me, please? What kind of?
Gamma rays, high energy light.
What's the name?
Gamma ray. Yeah.
Okay. It's kind of particles
Yes.
from the sky or something like that.
Yes, from the sky. Yep.
And what or why are you using the water
Because
to measure?
because we can't see gamma rays with our eyes, but when the gamma ray hits the water, it glows blue. It makes blue light, which we can see.
Yeah, I suppose that it's very interesting. Would you like to tell me more about it?
Sure. Yeah, we are making a survey of gamma rays from space, so where they come from, how much energy they have, and then we try to figure out what physics made them. And so there's a lot of high energy, particles in space whipping around, moving around and interacting with each other and making gamma rays. And so we can learn about the particles that made the gamma rays by observing, the gamma rays and how many we see. And there's a lot of different science you can do. I am looking for a signal in gamma rays from dark matter interactions. We haven't seen any yet, but we're still looking, because like I was saying, when particles interact, they can make gamma rays. And so we think that dark matter is a particle, like a proton or an atom. And we think that when dark matter interacts, that it could also make gamma rays. So we're looking for that. That's message.
Okay, it's very interesting. Would you like to tell me something about the measure of the gravity? Do you know? I suppose you don't work in Orizaba with gravity, but I know other science are already working with that.
Yeah.
Would you like?
Are you talking about gravitational waves, like what they detect with the LIGO experiment? Or
Yeah, I would like to know if you. I don't know if you would like to tell me something about the gravity.
Yeah, actually, so Hawk is looking. So it does relate to Hawk. So we have black holes, and when black holes collide, when they run into each other, they make what's called a gravitational wave, which is like a ripple, but with gravity. And this is made from black holes colliding, and in if it's a black hole and say a neutron star, which is slightly different than a black hole, you can also get gamma rays. And so we are looking for a gamma ray signal that happens at the same time as a gravitational wave signal from LIGO. And so that's actually a really interesting research that we do right now.
I'm very glad to talk with you, and thank you very much.
You're welcome. Thank you for the questions.
Bye.
Hello.
Me one time, sorry, because in the first time I was so nervous. Sorry.
It's okay. Está bien.
Okay. Can I know something about your work time?
Yeah, I am a scientist, and so I solve puzzles basically about the universe. I try to understand something new about the universe that no one's ever done before. I don't know if ¿Cómo se dice puzzle?
How many hours you work?
How many hours?
Yes.
I work 8 hours a day, 5 days a week. So I do a 40-hour work week.
Sorry, I'm thinking about another question.
Okay, take your time. I can do a dance. Yay.
I don't have nothing.
You can always come back. I'll be here all night.
Okay, I come back when I have another question.
Sounds good.
Bye.
Bye.
Ok, si alguien más gusta participar, es libre de hacerlo y los que no, los invitamos también a participar en la siguiente dinámica. Mi compañero que está preparando para acá y para ir Claro,
Hi.
Hello.
Hi, I'm Josue.
Hi, Jose.
I have a question for you,
Mhm.
please. What's the singularity of black hole?
So, black hole, you take, right, a lot of matter, and like you said, you put it down into a single point that we call a singularity. And what that does is it bends space time. Do you know the phrase space time? Anyway, it's like you put a trampoline a bowling ball on a trampoline. It bends the trampoline. Well, a black hole singularity bends space and time so much that not even light can get out. That's why it's black.
Okay, very interesting. Thank you very much.
You're welcome. Thank
Nice to
you.
meet you.
Nice to meet you too. Igualmente.
Bye.
Hola.
Tú también eres monitor, está ayudando. Pues,
Sí.
mira,
¿Le puedo volver a preguntar? Claro.
ayuda, porque necesito tener acceso aquí a esto, entonces que me ayude a entrar acá.
Hello,
Si no,
Jen.
Hi.
Hi.
Would you like to tell me about what do you do in Orizaba?
Yeah, we are observing high energy light from space called gamma rays. So these are signals from space from very interesting things like black holes, pulsars, and I actually look for signals from dark matter interactions. So we think that dark matter is what's holding our galaxy together. We know there's a lot of gravity, so there has to be something there, but we it doesn't have light. But we think that when it hits other dark matter, it could make gamma rays. So we look for gamma rays from places where we know there's dark matter.
Thank you. And what do you do, or what do you like to do better? Or what's the most interesting for you?
I really like coding. So, like computer programs, because we have so much data, I can't analyze it myself. I have to have a computer do it. And so telling the computer how to analyze the data, I think, is really interesting.
Analyzing, it's what you do?
Yes. Yep.
Oh. And about the water tanks, would you like to tell me something about it?
Sure. They are quite big. They're about the size of a T Rex, the dinosaur with the little arms. And there's 300 of them, and they're filled with water, and then they have 4 light sensors inside each tank. And so when the gamma ray hits the tank, we can see the light it makes because it hits the water and it flashes blue. And so we can see that blue light with our photosensors, our little light detectors. And then we actually see 20,000 flashes of light per second. So we get a lot of data.
And how many liters of water have each tank?
Let me try to remember. It's a lot.
It's a lot. I suppose they are big, really big.
Yeah. It's okay. It's about 200,000 liters of water. So
Each one?
each one. Yep.
And how many tanks do you have in Orizaba?
We have 300.
300 tanks.
That's right.
Or it's a lot of them.
Yes.
And, and if you get or you can detect a particle, most of the times you can see them in all the tanks or several of tanks or just one.
That
Each.
is a really good question. So when you have it depends on the energy of the particle. So a particle that has a lot of energy will light up all the tanks. But a particle that has only a little bit of energy will say only light up one of the tanks. And so it depends on the particle.
So I suppose it's a way to to know how many energy a particle have.
Exactly. Yes.
Okay. Thank you very much.
You're welcome.
Bye.
Bye.
está bien. Tiene un chorro de información. Puede ser.
Will you like to dance?
Yeah, it's fun.
What kind of music music do you prefer?
I am really I like all music. But I right now like Katy Perry and this rock band from England called Muse. I don't know if you know the Muse. They're really
Yes,
good.
I know this, and I like it too.
Yeah, good. Awesome.
How many scientists are working in Orizaba?
So there's an international collaboration of people working on Hawk, and I think there's about 200 of us. There are people from UNAM, there are people from America, and there are people from Europe. There are even people from Japan, all working on it.
And are you working in, I don't know how to say it, but 8 hours or 12 hours of each 24 hours? So how is your turn?
I work 8 hours a day, 5 days a week, so 40 hours. Um, we do, yeah, and we have people. So I don't work at Orizaba. I work, in America just through my computer. So we have the internet, and we can connect to the detector without actually being there. But we do have people who are there on site from Atizitla, and they are there 8 hours a day. So
Okay.
not overnight.
And how much money can you get as a scientist?
I make $150,000 a year,
Okay.
so pretty good
And
money.
do you think it's enough?
It's plenty, yeah, more than
Okay.
enough.
Okay. I don't know how much. Thank you very much.
You're welcome. Bye.
Yeah.
Se llama Mireya. Hello, Andrea. She's
Hello.
Mireya, and she has a question.
Okay, go
And
ahead.
the question is, ¿cómo puedes medir o detectar la materia oscura? How can you detect the black matter?
So how do you detect dark matter is the question. And right now, we only can detect it using gravity.
Okay. Ella dice que la materia negra solamente de momento se puede medir por medio de la gravedad. How does it work?
Well, we think that it is a particle and that the whole bunch of them come together and make kind of like a cloud. So you have a cloud
Okay.
of particles.
Okay. Dice que es una partícula oscura que es como demasiadas partículas juntas que generan como una nube, pero no hay luz en ella. Hay mucha ausencia de luz. Entonces así es como se detecta. Por medio de la gravedad, estas partículas se atraen y se genera esta nube oscura. Okay. Thank you.
Oh, you're welcome.
Gracias.
¿Cuándo se descubrió la luna?
Has a question and she wants to know when the humanity discovered the moon.
When did humanity discover the moon? I think we knew about the moon even before we were people, back when we were monkeys.
Dice que básicamente la luna se descubrió desde mucho antes casi casi los principios de las primeras civilizaciones y que como tal no hay una fecha específica, pero ahora sí que desde nuestros principios. ¿Le quieres preguntar la otra de...?
I'm not sure. Did I get the question right, or? Yeah.
Yes, she wants to know if there's extra life on the back of the moon.
That is a good question. So we can't see it from Earth, but we have sent robots and satellites out, and they've looked, and they haven't seen anything. So, as far as we know, no life on the moon. Sorry.
Dicen que la humanidad ha mandado robots y ahora sí que equipo para investigar para por ahí qué es lo que hay detrás, pero que por el momento no se ha descubierto nada. ¿Tienes otra pregunta que le quieras hacer? La que sea, tú la tengo. Okay. She wants to know how many black holes are.
Oh, billions. So think of pretty much every galaxy has a black hole in it, and there are billions and billions of galaxies, and so billions and billions of black holes.
Dice que hay millones, básicamente que en cualquier galaxia hay, por lo tanto, como hay muchas galaxias, también hay muchísimos agujeros negros.
Yeah, there's actually a million, roughly, in just our galaxy.
Dice que hay millones alrededor de nuestra galaxia. Okay.
¿Sí está bien el micrófono? ¿Y así se escucha?
Sí, claro, sí, claro.
Hello, how are you?
Hi, good, thank you. How are you?
Very good. Where are you from?
I'm from a laboratory called Los Alamos in New Mexico in America.
But how far is that from Juarez? Because I am from Juarez.
Juarez? I mean, we're maybe a 6-hour drive from the border, and so yeah, I'm not sure. Yeah, I think it's about 6 hours drive.
Oh, yeah, that's far. Well, I have a question.
Mm-hmm.
It's about the universe that is supposed to be expanding, right?
Mm-hmm.
So the other day I heard something about that. If the universe is expanding, something's gotta be contracting. Do you know something about that?
So you could think this was actually a big surprise for scientists is when we saw that the universe was expanding, because everything in the universe has mass, and so that means it has gravity. So it should be pulling itself in, not pushing itself out, right?
Right.
But
Yeah.
it's pushing out, and we're not entirely sure why. We have a theory that it's from something we call dark energy, and yeah, and it just means that there's something in between galaxies pushing that we can't see with our telescopes, so we don't really know what it is. There's some experiments that are trying to explore it in more detail, but yeah, so we are expanding, not contracting, and that's kind of weird.
Yeah, I know. Yeah, and I see science is not ready yet to answer those hard questions, right?
Right, yep, there's I call it job security.
Yeah, I know.
Always
And I have another question.
Okay.
The other question is about energy and matter.
Mm-hmm.
Like how supposed like matter is supposed to be like energy, right?
Yep.
But it takes a lot of energy to, how can I say, to accomplish some matter. Is there any relationship uh, different from what Einstein said about those two things?
Right, yeah, E equals MC squared. Einstein got it right as far as we know. Matter is energy, E equals MC squared. And what's really cool is that matter is a lot of energy. So, right, when you take an atom and you convert it, instead of being matter into energy, right, you have like a nuclear bomb. And so, you just have a lot of energy packed into each atom. So yeah.
Uh-huh. Yeah, and also I heard something about like that's a theory. I think that's the name.
Yep.
Where they were talking about having the strings vibrating in some kind of frequency, which means that you can perceive them as an atom or as something. But then if they change the vibration, you can perceive them as something else.
Yeah,
What
because
do you know something
if
about that?
you change it's kind of like when you're playing a guitar, when you play a different note, that string is vibrating differently. That's why it sounds different. Because it's
And,
so yeah, and so it's kind of like that where you have different particles, right? You like you said, the strings vibrate differently, so you get a different particle.
yeah, but do you know something about the perception regarding that? I mean, because let's say that something is vibrating in some kind of way. I am perceiving something, but then somebody else is perceiving something else.
Yep. Yeah. Right. Because yeah, you're seeing, say, photons from an object, and yeah, the photons you see aren't necessarily the photons your friend. Actually, they are not the same photons your friend is seeing, like you said. And then this gets into like neuroscience, science of the brain, where yeah, what you would say is green, like the color green, your friend might disagree. Actually, me and my husband disagree every once in a while. I'll be like, that's pink, and he says no, it's orange. So yeah, perception is a very interesting topic. And yeah.
Because perception has to do with the brain of the person, right? No, it's not supposed
Exactly.
to do with the vibration of the particle.
Yeah, right. That's a good point. The vibration of the particle is for lack of a better word, the truth, so to speak. It should be the same but then yes, how our brains absorb it and understand it, that's very complicated, and it's a really cool philosophy to think about.
Yeah, that's philosophy. Well, sorry.
Oh no,
Okay,
you're okay.
there's people in line. Thank you
Okay,
very much.
thank you.
Thank you, bye.
Hello.
Hello.
I just want to know if is there like more information or new discoveries regarding the moon hero of Jupiter?
Oh, the moon. Which moon of Jupiter? Hero?
Yes, hero.
Which I guess I. Oh, Europa. Europa?
Yes, correct.
Oh, sorry. Okay. I don't think there's really anything new on Europa. Europa is interesting, right? Because it's a bunch of ice, but
Yes.
underneath the ice, they think that there's water. And
Mm,
so, yeah, I remember hearing about a possible, satellite, like space experiment that they were going to send there called Ice Pick, but I don't think that it really took off and has been funded. So I haven't really heard much interest about Europa, to be honest, the past couple years.
Okay, yeah, no worries. It was useful. Thank you.
You're welcome.
¿Quieres hablar con ella? ¿Hablar inglés o te ayudamos a...? No hablo mucho inglés. Ah, bueno, sí lo entiendo. ¿Cómo te llamas? Ian Santiago. Hello, Andrea.
Hola.
He's Ian Santiago.
Hi, nice to meet you.
Mucho gusto en conocerte. Sandy,
Do you have a question?
¿tienes alguna pregunta? Sí, puede estar de nuestro lado, por favor. Claro. ¿A cuántos años luz está la última galaxia? Okay, do you know, Andrea, how many light years far away are the last galaxy?
So the closest galaxy to us is Andromeda.
And the
I'm
far
trying to remember. Andromeda, I think, is a million. Yeah, it's a million light years away. And that's the
Okay.
closest.
un millón de años luz. Sí, pero la más cerquita. Tú quieres saber la más lejana, ¿verdad? And he would like to know, do you know the further one?
Oh, the furthest one. Well, I guess the furthest galaxy is probably like 10 billion light years away.
Que cree que la siguiente es como 10 billones de años, de millas, de años luz. ¿Cómo cuáles son? ¿Como el nombre? And do you know their names? Like the name of the farthest galaxy?
Oh, I don't know the name of the furthest galaxy. It's probably very boring, like NC 17.
Okay.
Yeah, I don't
Dice
know.
que no se presenta el nombre porque tienen como números y es como que la 80, la 90. Ajá. ¿Alguna otra pregunta? La que tú quieras. Okay, then thank you very much,
No
Andrea.
problem. Thank you.
Gracias. ¿Puedes hacer otra pregunta? Gracias. Hola.
Hi again.
Hi, it's me again.
Did you have another question?
Yes. Can you tell me the difference between black matter and the galaxy or stars? Sorry.
Right. So the big difference is that stars give off light, right? Stars shine. They're luminous, and dark matter is not. It's yeah. It basically looks black. The other thing is dark matter tends to be more like a cloud, so it's lack of a better word, fluffy. Whereas stars are kind of packed tighter in, if that makes sense. They're more dense. I don't know.
¿Quieres que te ayude a explicarte lo que dijo? Dijo que la mayor diferencia entre una estrella y la materia negra es que las estrellas brillan y la materia negra no. Entonces, o sea, es básicamente ambas son partículas y son como un montón de partículas juntas, simplemente que una es más, o sea, una tiene luz y la otra tiene ausencia de luz. En una no hay nada de luz. Pueden estar juntas, y la masa oscura es la que rodea la masa. Todos los planetas, todas las estrellas son como partículas que tienen luz y todo lo que está alrededor, lo negro, esa es la materia oscura. Esa es la mayor diferencia entre
Why you choose be astrophysics?
I chose it because I like solving puzzles.
Do you like so much the space, the galaxy?
Yeah, I think that space is very interesting. Actually, and there's stuff in space that we can study that we can't study anywhere. Like we can't study here on Earth. For example, there's not a lot of dark matter at Earth, but there's a lot of dark matter in space. And so, if you want to study dark matter, in my opinion, the best place to do it is space.
Dice que sí le gusta mucho las matemáticas, que le parece algo muy interesante el espacio y que la forma más interesante de aprender sobre eso es estudiando le parece muy interesante la cuestión de que hay afuera del universo, pues que la mejor forma de hacerlo es estudiando astros. Okay, then this will be awesome. This will be it. Thank you very much.
This will be it. Thank you so much.
No problem. You're welcome. It was nice meeting you.
Mucho gusto en conocer.
I'll dance while you walk away.
Hola, ¿tienes una pregunta? Puedes sentarte y ella te va a responder. Puedes hacer la pregunta que tú quieras, de lo que tú quieras sobre el espacio.
Ah, ok, son los crean, ¿verdad?
¿Cómo?
Sería una inteligencia artificial.
No, es una persona real. Y si te sientas, te va a ver. y te va a responder la pregunta. Científico es lo que se especializa en materia negra, pero claro, para buscarle sobre la formación de estrellas, la actividad, los conejos, planetas, astros, constelaciones, la luna, la tierra, lo que quieras.
Hello, it's me again.
Hey, welcome back.
I just want to know if the Earth has like a risk of, I'm not sure, receiving damage or something like that by a black hole, or is there like a black hole close to the Earth, or which
Right.
one is the closest?
So the closest black hole, I would guess is maybe 100 light years away. If I had to guess, let me look it up. But as far as could they damage Earth, the ones in our galaxy, not at all. However, there are black holes. When they collide with other black holes, they make what's called a gamma ray burst. So it's a big explosion, and the explosion points in a specific direction. So if a gamma ray burst happened close to us and it was pointed at us, it could be bad. So possibly because of gamma ray bursts, I think is the biggest threat to the Earth as far as black holes go.
Yes, you said that happens if a black hole hits with another one, correct?
That's right, yeah.
Okay, nice.
Yeah.
Okay, thank you.
You're welcome.
I have another question, Andrea.
Please, yeah.
What will happen if a meteorite hits our planet? What will be like immediately like the immediate effect in us? It will be like a tsunami. Will be like an automatic like destruction. What do you think that will happen if a meteorite hits the planet?
Right. So it depends on how big it is. Right, because we have little ones hit all the time, but they burn up in the atmosphere. So they aren't a big deal. But if we had a really big one, if it hit the ocean, yeah, that would make a tsunami, like you said. And that's bad. And then it would also, so it wouldn't destroy the Earth immediately. It would make a lot of stuff in the atmosphere, and so it'll block out the sun, and then we can't make food anymore, and it becomes really cold, and then we all die off slowly.
Okay. And for example, I have another question. Probably you mentioned, yeah, like you already responded to this, but like if a small meteorite, such as I mean, I don't know, like the ones that have hit the planet before, hits the air, not the water, but the air. Will it be like an immediate effect, like for example, as the volcanoes when they explode,
Mhm.
like we have like these red skies and pollution and so, or will be like a fire or what do you think? I know this is not exactly your area, but what do you think would be happening?
No, I think it would be similar to, like you said, with volcanoes, because they put a lot of stuff into the air, and right, it makes it cloudy. I mean, there wouldn't be lava,
Mhm.
but yeah, if it hit and yeah, it would make a big crater, and it would just put a lot of stuff, a lot of dust and dirt in the atmosphere, and that would be bad.
Okay, thank you very much.
You're welcome.
Okay.
¿Qué le quieres preguntar a la
Hello.
experta?
Hello.
Hi.
Hi.
How are you? ¿Cómo
¿Cómo
está?
está?
Bien.
Bien? Muy bien or just bien? Solamente bien o muy bien?
Bien.
¿Cuál es la pregunta que le quieres hacer a la experta respecto al espacio, de las estrellas? ¿Qué te gustaría saber de las estrellas?
Antes,
¿Quieres ver el telescopio? Ah, o sea, tú quieres ver las estrellas en el telescopio. Ok. ¿Me ayudas para guiarla con... Ajá. Es que de este lado están los telescopios.
Si tiene que ir por ese lado, por favor, para
Ah, sí, bueno. ¿Me ayudas?
claro, sí, acompáñame, los quieren enseñar a verlos. Y ya te paso.
Bye.
Entonces, ¿quién sería el siguiente? Jaime.
Ay, no, no,
Sí, puedes.
Hello.
Hello.
Hi. How are you?
I'm fine, but I don't know a lot of words of the universe. Can I say in Spanish?
Yes. Wait, is there someone there to translate? I think there is.
Yes.
Oh,
Si quieres,
you were a little off camera. Okay, yeah, please go ahead.
Si el universo está en expansión, ¿qué tanto se va a expandir o qué va a ocurrir con el universo? ¿Se va a volver a reagrupar o se va a hacer plasma o se va a esfumar? ¿Nos congelaremos? ¿Qué va a pasar?
the universe is in constant expansion, and he wants to know what is going to happen, like once these expansions like arrives to the limit. Is
Posibles
yes,
escenarios.
like possible scenarios.
Well, so the question is, the universe is expanding, and is there an end to that? Right now, we think it's just going to keep expanding forever until everything is as far away from each other as possible and as cold and lonely.
¿Quieres que te ayude?
Sí, con el final.
Dice que el universo ahora sí que se va a expandir y mientras más se expanda, ahora sí que lo único que pasaría, que por el momento esta información es que van a quedar,
Sí,
van a quedar, sí, van a quedar de que muy distantes. No entre otros.
gracias. Mira.
Hi there. Hi.
How are you?
I'm good, thank you.
Fine. I am beginner in these topics. Okay. Okay. My question is, what is the black matter?
So dark matter is what holds our galaxy together. All the stars are moving very fast, and if there were no dark matter, they would fly off into space and we would not have a galaxy.
Okay. Perfect.
Yeah.
Thanks.
You're welcome.
That's thanks. Good morning.
Thank you.
¿Quieres que te ayude a traducir?
Gracias. Hi.
Hello. How are you?
Everything fine, thanks. And you?
I'm great.
That's cool. I have a question. What is the most or the more current experiment in the dark matter that we have?
So right now I'm working on an experiment called Hawk, which is actually located near Pico de Orizaba, just up the mountain from a little town called Atzizitla. So yeah, Hawk is running right now. We're taking data. We've been taking data since 2016, so it's been, like 6 years. So that's one. Let's see. They have other experiments that are underground, like way underground in a mine, and so that's something called Lux. That's down in a mine. I don't work on that one, but yeah, they have to go deep because they're looking for dark matter to interact with their detector, and a lot of other particles interact with the detector from the atmosphere, and so they have to go down to avoid them so that they can just see dark matter.
Wow.
There is also experiments. Large Hadron Collider in Switzerland and CERN that discovered the
Yeah.
Higgs boson. Yeah, so they look for dark matter um, with the Large Hadron Collider. So there's a whole bunch of different ways to do it, and yeah, a lot of experiments going on.
And what is the PhD that I have to study to to know about it or to have this
Well,
research
yeah. So my PhD is in physics.
in physics?
Yeah, so physics or astrophysics. Yeah.
Okay.
Or
Thank you so much.
astronomy. You're welcome.
Nice to meet you.
Nice to meet you too.
Bye.
Bye. You're back.
Sorry,
No,
they're
you're
taking up. Hi.
Hello, how are you?
Oh, fine, thank you. And you?
I'm doing great.
That's good. My question is that is something, well, I know that nothing is faster than the light in the universe, in the space, but no, one physic told me that the light was um, slow in the water. No.
Nope, yep, that's right.
Can you understand me? That it was something faster than the light in the water
Yeah.
that I don't know. Uh-huh.
Oh, sorry. Yeah, so you're asking about a thing. It's called Cherenkov radiation. So it's named after a Russian guy named Cherenkov who found it. Yeah, and so right, you have the like you said, the speed of light in space, right, in a vacuum where there's nothing, is the fastest anything can go. But even light, when light goes through water, it slows down a little bit. It's called an index of refraction. Anyway, but what you can have is you can have a particle that goes from, not being around things and then is suddenly into water. It's moving faster than the speed of light in the water. So it's not going faster than light in space. Can't go faster than that, right? But yeah, if you go faster than light in water, you give off this blue flash called Cherenkov radiation.
Okay, thank you so much.
Oh, you're welcome. Hope that
Thank
answered
you.
your question.
Hello, how are you?
Hi, I'm good. How are you?
I'm very well, thank you. Well, I have a question, of course.
Yeah.
And my question is, why is important to the entropy in the universe? For example, I mean the problems that the astrophysics have with the entropy, trying to explain about neutron stars or other kind of stars. I don't know if I explain my question, but I'm curious about it.
Yeah, so you were asking about entropy.
Yes.
Yeah, and how it applies to stars. Yeah, because it's interesting. I remember doing, when I was in classes, learning about neutron stars. Because yeah, the entropy of the neutron star, I believe it's pretty ordered. Like it's basically like it's a big neutron. But yeah, and it's interesting too because the entropy. So okay, and this doesn't have to do with stars, but I had a little girl once ask me. I broke a glass and it shattered, right? And she asked, "Can you put it back together?" And
Okay.
right, because when the glass was shattered, that was a lot of entropy, and so reducing the entropy, you can't do that. It has to stay the same or get larger. And so I was trying to explain to her that if we put the glass back together, it would take a lot of energy because of entropy. But But yeah, I don't know too much about how entropy works with stars. But anyway, I hope that was a fun story.
Okay, thank you.
You're welcome.
Bye bye.
Bye. Hello. Hi. How are you?
Hi, thanks. And you?
I'm great, thank you.
Um, uh, I have a little question. I don't know. Existe? Is some study of what is inside in a black hole?
Yeah.
Evidence. The only reference. The only reference I have is the movie of Interstellar.
Right.
It's the only.
So what's inside a black hole? The short answer is we don't know.
Okay.
Because light can't escape. So right, we can study stars because we look at the light that comes from them, but there is no light from a black hole. It's stuck inside the black hole. It won't let it go. And so
Okay.
we can't see inside a black hole.
Okay.
Yeah.
Okay. Okay, it's okay. No problem.
So, but we had to use our imagination, like in Interstellar.
Okay.
Yeah.
The movie Interstellar.
Yeah, it's a
You
great
have some.
movie.
Yes. You have some Facebook, Instagram to follow you.
Oh no, I don't. Sorry.
Okay, no problem. Okay.
I'm
Thanks. Thanks a lot.
You're welcome.
Bye.
Thank you.
Siento, te adelantas si no hablas inglés, te ayudamos otra vez.
Nosotros pegamos la screen.
Hello.
Microphone.
Don't be shy.
Buenas noches. Hoy, ¿por qué es tan oscuro el universo?
He's asking why the universe is so dark.
Because I guess there's a lot of space in between stars.
La respuesta es que hay mucho espacio entre una estrella y otra.
I don't know if that makes sense.
¿Cómo determinaron la velocidad de la luz?
¿Qué?
¿Cómo determinaron la velocidad de la luz?
¿Puedes hablar un poco más despacio?
¿Cómo determinaron la velocidad de la luz?
¿Cómo determinar la velocidad?
¿Cómo la determinaron?
He's asking how did you determine the speed of light?
That's a good question. You can, so right now, you can define it using atoms and interactions inside atoms. And so you have like an electron moves within the atom, and you can figure out how quickly it moves, and that tells you about the speed of light.
Dice que en realidad lo determinan a través de átomos, a través de cómo un electrón se está moviendo dentro del átomo y qué tan rápido ese electrón se mueve. Entonces, a través de haciendo esos cálculos, pudieron determinar la velocidad. Thank you.
You're welcome. Hi.
¿Cuál es tu pregunta?
Hola.
Sí. Hola.
¿Cómo estás?
¿Le quieres hacer una pregunta a Andrea acerca del espacio? ¿Cuál es tu pregunta?
¿Por qué puede explotar?
¿Por qué puede explotar?
Flotar.
Flotar. He's asking why space can float.
So in space, the astronauts float because they're there's zero gravity, I guess. But it's because they're going around. So it's like they're in imagine an elevator that just falls and only falls and never hits a bottom. You float, right? And so if we call that free fall. And so astronauts in space are in free fall. I don't know if that.
Lo que ella está diciendo es que en el espacio estás flotando y
por ejemplo, si tú fueras un astronauta y salieras al espacio, flotas porque no hay gravedad, es cero gravedad. Pero la manera en que tú te lo puedes imaginar es como si estuvieras dentro de un elevador que estuviera cayendo constantemente. Eso ellos lo denominan como caída libre. Entonces, si alguien sale al espacio, es como si estuviera cayendo constantemente, pero nunca va a llegar a nada porque el espacio es infinito. Eso es todo. ¿Tienes alguna otra pregunta? No. Ok.
Thank
Gracias.
you. Nice to meet you.
Gracias.
Hello.
She's asking what an astrophysicist does.
Well, I do a lot of computer programming because I can do the math, but sometimes I have to do math a million times, and the computer's faster than me, so I just tell the computer to do it.
Ella dice que más que nada ahorita se dedica a programar computadoras o hacer pues como programación, porque ella puede hacer todas las operaciones matemáticas que se requieren para la investigación, pero la computadora es mucho más rápida haciendo que ella. Entonces se lo pasa haciendo programación de computadora para que haga las matemáticas por ella. Gracias. Thank you.
Yeah, no problem. Bye. Hi.
Sí.
Puedes preguntarte, por ejemplo, la materia oscura nos puede desintegrar y cómo nos desintegraría, si es que nos desintegra la materia oscura.
Okay. She's asking if it's possible that dark matter can disintegrate a body, and if it is, how would it work?
So, dark matter we call it decay, but it is basically disintegrating. So we think that dark matter could do that, but it doesn't do it very often, which is good because we need dark matter to hold the galaxy together. Was that the question? Was like, does dark matter disintegrate?
Yes, I think it was.
Okay.
Let me.
So it can, yes, but not very often. Yeah.
¿Quieres que te traduzca la respuesta? Sí. Dice que sí puede hacerlo, o sea que ellos lo usan otro término que no es como desintegrar, sino más bien como decaer, pero que no lo hace muy seguido. Y que básicamente la materia oscura pues se encarga de mantener junta la galaxia. O sea, sí puede, pero no lo hace muy seguido. ¿Quieres que pregunte que si lo hace, cómo sucede? Ajá.
And in the cases where it does decay, how does it work? Do you know how it works, or you're still figuring it out?
Well, we don't even know if it does. We've never seen it decay, so we're still figuring it out. Yeah, lots of questions.
Okay, so it's just like a possibility, but you haven't actually
Seen it. Yeah.
seen it.
That's right. Yeah.
Okay, thank you.
Oh, you're welcome.
Dice que es una posibilidad, pero como nunca lo han visto suceder, aún no saben cómo funciona.
Okay. Thank you.
You're welcome. Bye.
Sí, sí, sí.
¿Lo puedes traducir?
Sí.
No tengo la confianza.
Hi.
Hola.
Hello.
Es algo simple, pero que también.
Ok, haré mi mejor esfuerzo.
Si tuviera yo una casa en la luna, ¿cuántas horas serían de luz y cuántas horas serían de oscuridad o días? No sé.
Okay. He's asking if he would live on the moon and have a house there, how many hours of daylight and how many hours of night would he experience?
or days?
Right. Let's see. So you're always going to look at the Earth. Okay, sorry. Okay, I guess let's see. Sorry, I haven't thought about this before.
Take your time.
So the moon, right? There's a side of the moon that's always away from Earth, and so the moon we call it tidally locked, so it's kind of stuck in one. But if you are on the moon, I think it's about the same as Earth.
All right. So the moon doesn't it rotate?
The moon, like, so right, the Earth rotates and you get days, but yeah, no, the
moon doesn't.
no, the
Oh.
oh.
O sea,
It's locked because of tidal
Yes.
forces.
Yes, they just explained it to me.
Oh, okay.
Thanks.
Yes, sorry. I didn't do a good job.
¿Le entendiste o quieres que te traduzca?
Pero no escuché. ¿Qué?
No, nada, o sea, yo tenía la duda, es que yo tampoco estudié física, entonces no tengo idea, pero tenía la duda de que si no rotaba, solo se trasladaba. Pero parece que sí lo hace, pero al mismo nivel de la Tierra, de esa forma, de un lado, siempre está viendo hacia la Tierra y el otro lado no. Pero dice que si estuvieras en la Luna, las horas de luz y de oscuridad serían parecidos a la Tierra.
Okay.
No sé si igual, pero parecidos.
Okay. Thank you.
Thank you.
Okay, yes. Thank you.
Hola. ¿Quieres que te ayude a traducir una pregunta? Sí, ¿cuál es tu pregunta? ¿Quieres decir hola? Sí, hola.
Hola.
¿A qué distancia está el Sol de la Tierra?
He's asking at what distance is between Earth and the Sun.
The distance between Earth and the Sun is
Yes, exactly. Sorry.
It's 8 light minutes, but it's also it's about 100 miles. Million miles, sorry, 100 million miles.
100 million miles. O sea, hay dos formas. Ajá, 100 million es 1 millón de millas o 8 minutos. 100 millones de millas. ¿Y cuánto está en kilómetros?
Oh, do you know that?
160 kilómetros. No, 160 millones de kilómetros.
Thank you.
Oh, you're welcome.
La otra pregunta que ¿quieres hacer otra? Puedes hacer cuantas tú quieras.
¿Qué materias se necesitan saber para ser astronauta?
¿Qué materias? ¿Cómo se traduce materias? Como what topics? Signatures. Ajá. He's asking what signatures do you need to know to be an astronaut?
Well, you need to know a lot of math.
Just mathematics?
You're right. Yeah, you need to know science. And you need to know how to solve problems quickly.
¿Y cómo resolver problemas rápidamente?
Especially if you're stressed. If it's dangerous, you have to solve problems. Really.
Especialmente si estás en una situación estresante, tienes que saber resolver problemas aunque estés estresado.
But you also you need to be athletic.
Tienes que ser atlético.
So yeah, it takes a lot to be an astronaut.
Necesitas muchas cosas para ser un astronauta. ¿Ya? ¿Te quieres despedir?
Thank you.
You're welcome. Bye.
Gracias.
¿Quieres enviar perico? Bueno. ¿Le pregunto? Hi, Andrea. They are asking about your last name,
Oh, Albert.
Albert.
Yeah.
Great. And where do you work?
I work in the United States at a laboratory called Los Alamos in New Mexico.
Great.
Yeah.
And somebody else asked me, what is the best part of being a physicist? At least for you.
Right. I like solving puzzles, like I said, but I also like the people I work with. Scientists, we're all working together, so I'm not just by myself. I work with other people all the time, and it's fun to be in a team and solve problems together.
That's awesome. I think quiero hacer una pregunta. Oh, they just asked, what would you be if you weren't a physicist? Have you thought about that?
Yeah, let's see. If I weren't a physicist,
Weren't.
I actually think I might be a pretty good lawyer because I like to argue.
That's a good answer. ¿Nadie más quiere hacer preguntas?
¿Me puedes preguntar? Sí,
Sí.
no nada más los que conocemos, ¿verdad?
Bueno, sí. Pues siéntate y pregúntale. Sí. Hace una pregunta también. Sí, hola.
Hello. Hi.
Ay,
Si quieres te ayudo.
Gracias. Preguntarle eso.
¿Qué quieres preguntar?
Si es que hay de verdad vida en otros planetas cercanos a nuestra Tierra.
She's asking if there is life on other planets.
Probably, but we don't know for sure.
Probablemente, pero no saben. Ajá, no están seguros.
Thank you.
You're welcome. Hello.
¿Quieres intentar preguntarlo en inglés?
ay, no soy buena. No soy
Puedes intentarlo y si no, yo te ayudo. También puedo ayudar.
Ay, ¿cómo digo en inglés? Sí, no, soy muy mala. No.
Bueno, dímelo en español.
Sigue, sí, o sea, ay, ¿cómo entiendes la pregunta más?
¿Dónde pueden ser un planeta?
Sí, Plutón deja de ser un planeta. O sea, sí, Plutón deja de ser un planeta.
Ajá. She's asking if Pluto is a planet or if they stopped considering it as a planet.
Yeah, unfortunately, we don't call it a planet anymore. It's smaller than a planet. And there's actually a lot of other things like Pluto out where it is, and those aren't planets either. They're also what we call dwarf planets. So it's not a planet, no.
Dice que ya no lo consideran como un planeta y que de hecho hay muchas otras formaciones en el espacio cerca que tienen el mismo tamaño y que tampoco son considerados como planetas simplemente porque son pequeños y los llaman planetas enanos.
Gracias.
Thank you. Bye.
No sé, ¿alguien más quiere hacer esta pregunta?
Hi. Hola.
Hi. Why are you using lobes?
Why am I using lobes?
Gloves? This is guantes?
Oh,
Gloves.
gloves. I'm sorry. Because it's winter and my hands are cold.
Thank you.
You're welcome.
¿Por qué existen estrellas? Las estrellas.
Okay. Hi. She's asking why some stars are red and others blue?
It's because of how hot they are. You can think of, so you have fire, and fire can be red, it can be yellow, it can be blue. It depends on how hot it is, and that's the same with stars.
Oh, that makes a lot of sense. Dice que eso depende completamente del calor, de qué tan calientes sean. Es igual con el fuego. Ves que a veces el fuego es rojo y a veces es azul y a veces es... Ajá. O sea, todos son calientes porque el fuego también en cualquier estado va a ser caliente. En la estufa, por ejemplo, se ve azul, pero sigue siendo caliente. Pero subiendo la temperatura cambia. Es lo mismo con el fuego. Son calientes. Todas son calientes, pero unas son más.
¿Y el azul es menos caliente?
Creo que sí, pero le podemos preguntar. One further question is, the blue stars then are less hot than the red star?
It's the other way around. Actually, the blue stars are hotter.
Hotter. Oh, awesome.
Yeah.
Yes, yes. Los azules son más calientes.
Okay, thank you very much.
Thank you.
Another question just came in, and it is, why don't we shoot nuclear waste into space?
Right. So yeah, why don't we shoot nuclear waste into space? Well, I
Yes.
guess I'm not sure, but I can offer my thoughts. It's really hard to put things into space. Like, right, you think about if we just want to put a couple people in space, we need this huge rocket with lots and lots and lots of fuel. And so, if you're trying to get rid of waste, you would probably make more waste getting it into space, so that wouldn't be good.
That makes total sense.
But then I guess also, yeah, because if the nuclear waste is, unstable, you don't want to put a rocket around it. I don't know if that would be dangerous to, rocket explosion plus nuclear waste might not be. Yeah, it might not be the best combination.
Yeah, that makes complete sense. Thank you.
No problem.
¿Quieren hacer otra pregunta? Hi again.
Hello, welcome back.
Hello. Thank you. I remember another question about, I read in the news that they have in a lab recreated a black hole, but I cannot understand how is that possible.
So you're saying they made a black hole in the lab. So I guess I haven't heard of that, but is this a thing with the quantum computer?
Maybe yes, but this is they recreated in experiment. That's why I was like thinking, is it dangerous if they try to recreate?
Well, so there are theories, and as far as I know, it hasn't actually happened yet. But if you make a really, really, really small hole, it will disintegrate. It'll evaporate almost immediately, and so so depending on, but yeah, but as far as like making a Earth-size black hole, no one's done that. But yeah, if you made a really big one on Earth, that would be bad. But you can make itty bitty little ones. But as far as I know, we haven't done that yet.
But if they recreate a little one, it doesn't happen. It doesn't matter.
That's right. Yeah, it just dies fast.
Okay.
Yeah.
Interesting.
Mm.
Yeah. So thanks. I just have to that.
Great question. Yeah.
Thank you. Bye.
Bye.
Bye again. We are gonna search for more people so they can ask you more questions.
Okay, great. Thank
Hold
you.
on.
Yeah.
No, thank you. It's an honor. Sí, necesitamos orientar.
Sí, excelente.
Hi
Hi.
again.
Sí, Oye, ¿qué ocurre con el espacio-tiempo en los agujeros negros?
Hi, Andrea.
Hi.
Just what happened with the time-space in the black holes?
So, okay. Imagine, do you know what a trampoline is? You bounce on it, you jump, and it's springy.
Yes.
Yeah. Okay. If you So the trampoline is space-time, and if you put a bowling ball on the trampoline, it bends the trampoline, right? Okay. And so a black hole is like taking a bowling ball but squeezing it down to the size of like an atom, so it bends it really far right in the middle.
Que prácticamente dice que el espacio es como un trampolín y cuando está un agujero negro es como si pusieras una esfera muy pesada en el trampolín, entonces eso distorsiona la superficie y esa superficie es el espacio-tiempo, entonces prácticamente es una distorsión de ese fenómeno. Y era por esta pregunta, ¿no? El espacio-tiempo básicamente es una...
Se altera.
Un físico, ajá, y se altera por la mera existencia del agujero negro.
¿Y qué le pasaría a un humano si fuera tragado por el espacio-tiempo?
And what could happen with a human if he throws for a black hole?
So if a person approached a black hole, so right, the gravity would get stronger and stronger and stronger, and it would get to this point where it's so strong, it's much stronger at their feet than their head if they're going in feet first, so they would get stretched like spaghetti.
Prácticamente la fuerza de gravedad sería tanta y tan fuerte que se convertiría en una especie de espagueti. Su masa reduciría mucho y sería como un espagueti pequeño.
Un espagueti, pero quedaría uno atrapado en un bucle.
The human will be in a kind of jail, something like that.
I guess if you get inside the black hole, you can't get out. So it's kind of like a jail? Is that the question?
Yeah.
Yeah.
¿Qué pasaría con un humano si está un agujero negro? Entonces, ¿qué forma de rotura?
Pero dijo que no saldría, es que no sabe.
Ah,
Porque todo lo que entra a un agujero negro
o sea, como ni siquiera pueden verlo porque toda la luz que entra y no sale. Entonces, como imposible.
No se sabe.
No se sabe.
Ah, ya. Gracias.
Sí, no sale. Dile, thank you.
Thank you.
Thank you. Bye.
Bueno,
Hello.
ellos
Hi.
quieren preguntar. Quiero saber qué tienen que ver
She wants to know if the astronomy have some relation with the astrology.
Well, they both use stars and planets, but the difference is that astronomy we're talking about physics, so like the motion, the gravity, how they attract, and astrology is more of a philosophy, so it's not like a physical science. But they both use stars.
La relación es que ambos estudian las estrellas, pero la astronomía estudian vectores, movimientos, mientras que la astrología es una especie de filosofía. Básicamente pero la relación.
Ok, una pregunta muy general.
Oh,
Es que te está viendo. Ah, hola.
hi.
¿Cuál es la materia oscura? O sea, en sí, ¿qué podría ser la materia oscura? ¿Qué podría ser? ¿O qué definición? Ajá, tienen de la materia oscura. She's asking about the definition you have about dark matter.
Mhm.
What is it?
Well, we don't know exactly. We know that there is something holding our galaxy together like glue, but we can't see it like we see stars because it doesn't have light.
¿Entendiste la respuesta? ¿Quieres que te la Sí, sí la entendí. Va, sí entendí. ¿Quieres preguntar algo más? Pues es que en sí no saben lo que es la materia. No saben porque no tienen luz, pero saben que hay algo. Entonces, como partículas. Ajá, sí. Ok. Gracias.
De nada.
De nada. O sea, simplemente no aspira, o sea, no refleja luz. La materia oscura no refleja la luz, o porque se puede.
He's asking why does dark matter just if it just doesn't reflect light, or why can't you observe it?
Right, so it doesn't reflect light. That's right. It also doesn't like create light. So so we can't see it reflect light. But we can see it pull on things with its gravity.
O sea, lo que dice es que justamente no refleja ni produce luz. O sea, saben que existe porque tiene un efecto en la gravedad.
Ah, ok, esa es la razón por la que saben que existen.
Ajá. O sea, saben que existe porque hay algo que mantiene la galaxia junta. Si no, o sea, no, más que en equilibrio,
O sea, son como capas.
lo mantiene, o sea, tiene que ver con la gravedad. Pero si no lo pueden observar porque no tiene luz.
Entonces realmente tiene un uso, o sea, realmente nos funciona.
Sí, existe. O sea, y es lo que mantiene la galaxia.
La materia negra en sí es lo que hace que la...
Porque la galaxia es un conjunto de estrellas, si no, no estaría organizado de eso. Pero no saben exactamente qué es porque no lo pueden observar.
Entonces, ¿me saben exactamente qué es? No pueden saber si está compuesta de neutrones, electrones, protones.
Pues supongo que no. So somebody's asking if you can't know exactly what dark matter is, so you cannot know of what it's made, like if it's made of protons, electrons, or something else. But
Well, we know that it can't be protons or electrons. It can't be any particle that we know about and that makes up us and makes up atoms. It can't be anything that we know that makes up us. Yeah.
O sea, ella dice que no saben de qué está hecho, pero saben que no está hecho ni de protones, ni de electrones, ni de cualquier partícula que nos componen a nosotros. Ajá, porque es otra cosa. O sea, porque eso sí los puedes estudiar porque sí tiene que ver con la luz.
Solamente no es materia, entonces ¿es materia o es materia?
Es materia oscura. Sabemos que no sabemos qué es. Y que no es materia como el resto de materia que componen las cosas. Y las partículas.
Yeah, it has to be something completely different.
Tiene que ser algo completamente diferente.
Sí, yo quiero preguntar algo.
Ajá, ¿te quieres sentar?
A ver si.
Hi.
Es que también.
Hola.
Hi.
I want to know if there is in the space something material in a fluid shape or in a fluid in state in a fluid state.
Yes, there. So actually, at least in physics, we consider gas to be a fluid, and so there is a lot of gas in space. There are things called like nebulas, which are these clouds that get formed after a star dies, that are just made of gas, and they're quite beautiful.
Thank you.
You're welcome. No problem.
¿Cuál es el metro que es cuando te dan más? Cuando le señales.
¿Cómo le hace para funcionar o cómo hace que se revuelva como la materia?
¿No te quieres sentar? A ver, porque ella es la que te está haciendo esa pregunta.
Hello, how are you?
Puedes decirle hola.
Hola. Yo quiero saber cómo se une como nuestro universo con la materia oscura, o sea, cómo hace que haya como esa unión para que pueda como sostenerse así, o sea, ¿qué hace que se unan?
Okay. She wants to know, how does dark matter relate with other matter in the universe? Like, do you know how it works, that it keeps the galaxy together, or is it a mystery?
Well, we know it. So when we say keeps the galaxy together, we know it interacts with gravity, and so we can see it pulling and interacting with other things through gravity. But that's the only interaction we've actually seen. We're still trying to figure out what else it does.
Ella dice que lo único que saben es que la materia oscura interactúa con el resto de la materia que sí conocemos por medio de la gravedad. O sea, esa es la relación que ellos tienen, pero aún no saben de qué otra manera se relacionan.
Pues y es que realmente sería como, si no, simplemente se iría todo, la gravedad es lo único que tiene realmente.
Exacto.
Solo todo volaría y ya.
Exacto. Por eso sí se relacionan, por eso saben que tienen una relación.
¿Y qué pasaría si fuera así? ¿Qué pasaría si realmente, o sea, solamente no existiría nada o solo fuera diferente?
Ajá. She's asking, what would happen if there wasn't dark matter?
Oh,
there didn't exist.
If it didn't exist, we would not exist. There would be no galaxies. There would be no stars. Yeah, you need dark matter to make our universe. Yeah.
No, dice que tal cual no existiríamos. Si no existiera la materia oscura, no existirían ni las estrellas ni nada, ni las galaxias.
Tal y cómo saber cómo llegó la materia oscura aquí.
Ni idea. ¿Cómo existe? Probablemente no. Puedo preguntárselo.
Ajá.
¿Cómo existe la materia?
And how does it exist? Like, where does it come from? I guess it's a mystery as well.
Well, we think it gets made in the Big Bang. So right there, when the universe first started, right, there was a big explosion, lots of energy, and we think the dark matter was all made during the Big Bang. Yeah.
Que sí, que se generó en el Big Bang. And the further question is, how did the Big Bang originate?
We don't know. That's a good question.
Rayos, muy bien lejos. No saben.
No saben.
Yeah.
¿Cómo se originó el Big Bang? Pues es que me dices el soy pues ¿Ya? Puedes despedirte.
Thank you. Bye.
Thanks.
Hello.
Ah, ella te está viendo.
Hi.
So I'm a physics student, and I'm interested in computational physics and simulations of systems, and specifically in relativity systems and there's things like that. And I was wondering how, in a simulation, I don't know, in about the expansion of the universe, how does the dark energy or dark matter influences this simulation, or how to compute this phenomena?
So yeah, they do simulations of what's called large scale structure. And so there's actually, I think, a team of people at Stanford University that do this. And they kind of look at what happens if you just start with a bunch of matter, just sort of randomly isotropically distributed. And then you turn on gravity and you see it, come together and start to make these little clumps. And you actually end up, so the clumps become galaxies, and then in between galaxies, they're connected by, they call them filaments. So check out like large scale structure simulations. I think you'd be interested in that.
Dark matter is actually compatible with simulations of the universe? Or...
Well, I guess so. I would almost yes, we do some, and it's one of those things where we originally didn't have the dark matter in there, but we looked at the universe and we were like, this doesn't make sense without dark matter, so we had to put the dark matter. So it's kind of like nature told us how to do the simulations, but then we say, okay, well, if we understand gravity as well as we do, then dark matter should give this effect, and we see it in space. And so I guess what I'm just kind of talking about the interplay between observation and simulation, but yes, our simulations do match what we're seeing, and so we think we understand dark matter's gravity pretty well.
Okay. Thank you.
Oh, you're welcome. Good luck with your studies.
What?
I said good luck at school.
Oh, thank you.
Work hard.
Ay.
Bueno, es que hace unos días salió como un paper que hablaba de la creación de un agujero de gusano en un laboratorio, creo que de Google, ¿no?
En una computadora cuántica.
En una computadora cuántica de Google. Y queríamos como que saber la opinión de ella.
Hace unos días salió una noticia.
Un artículo.
Un artículo. ¿Cómo se dice agujero de gusano en inglés? Wormhole. So a few days ago, a paper came out about a wormhole. ¿Fue creado? ¿Se descubrió?
The creation of a wormhole.
A creation of a wormhole.
In a Google...
In a quantum computer. I think I know what you're talking about.
He's asking about your opinion about that.
Right. There's a fantastic article in the New York Times about it. And so, what I will say about it is that they didn't make a real wormhole, they did a computer simulation of a wormhole. So they made a, it's not like they made it, it only was it, and it was a simulation, but they did it with a quantum computer, which is really cool and has never been done before. And quantum computers are awesome, and I'm glad that we're learning how to use them better. But it wasn't a real wormhole, it was just a simulation.
So that makes me wonder, how does quantum computers work? Or what are they to start?
So I don't know too much about them myself, but they so when you have a computer, all of it is done with bits, they call them. So you can either have a 1 or you can have a 0. And then you make a big string of 1s and 0s, and then then the computer says, okay, that string corresponds to the letter A, and so that shows up on your screen. And so there's only so much you can do with only 1s and only 0s. And quantum computers, I'm trying to remember how many bits they have, but they have more than 2. Bits, and so there's a lot of different combinations that you can do, and so you can do more powerful calculations with them because it's not just 1s and 0s. Yeah,
that's awesome. That was a very good explanation. Thank you.
Thank you. Bye.
You're welcome. Bye. Hello.
Mira, sí, ella te está viendo.
Hi.
Okay.
El centro de la galaxia.
What is... He's asking, what is in the center of the galaxy?
Oh, a black hole.
At the center.
A black hole.
Un agujero.
No. No me lo sabía, aunque parece un agujero blanco.
¿Por qué dirías que parece un agujero blanco?
Porque el centro es blanco.
¿El centro es blanco?
El centro de la galaxia es blanco.
Ah, tú dices en el centro de la galaxia, no del universo. Ah. Sí, tú me preguntas eso. Ah, ok. Entonces, pero el universo no tiene centro, ¿sí? And another question would be, what is in the center of the universe? At the center.
Right. No, I don't think the universe has a center.
Yes, that's what we thought.
Although,
if there was a Big Bang, why wouldn't have it a center?
So it's complicated. The Big Bang, it wasn't just like atoms that were inside the Big Bang before it exploded. It was space and time itself was also in there. And so you can think of it as like, okay, so say, maybe it's not a great example, but, say you just have the surface of a balloon, right? We don't care about the inside of the balloon. We have a surface of the balloon. And as you blow the balloon up, if you draw 2 little dots on the balloon and you blow it up, they're going to get further and further away. But you wouldn't say there's a center.
Working to create a vision or vision.
I don't know if that makes sense. That's a bad analogy. But.
It does. Es que ahorita yo le pregunté que qué hay en el centro del universo, pero la respuesta fue que el universo no tiene un centro. Y entonces nos surgió la duda de, ok, pero si hubo un Big Bang, si se originó de un lado, ¿por qué no tiene?
un centro. Y entonces me explicó, y esto tiene que ver con la expansión del universo, que si tienes un globo y le pusieras 2 puntos a este globo y lo inflas, estos 2 puntos se empezarían a separar. Ajá. Entonces esto es como que se está expandiendo, pero en realidad, si piensas en toda la superficie del globo, sigue siendo una superficie, no tiene como un centro. Entonces, por eso.
was taken by the Curiosity rover from the surface of Mars. And we're actually in this picture. If you can see, we are about tiny little spot. And
¿Quieres despedir?
at the bottom of the surface
¿Quieres despedir o quieres hacer algo?
we're working to say observation subject to the robot.
A ver, inténtalo.
There's a lot that's going to happen. There's this long and winding path between the two places to fill this
Component for materials. ¿De qué está compuesto? ¿De qué material está compuesto una estrella?
Of what materials are stars made?
Yeah, so stars are mostly made out of an atom called hydrogen.
La mayoría están compuestos, o sea, mayormente están compuestos por un átomo que se llama hidrógeno.
But there's also some helium in there, but it's mostly hydrogen, yeah.
Bye.
Okay, bye. Thank you. Hello. Hi.
Hi. Hi. How are you?
I'm good, thank you.
I'm really glad to hear that. Well, I have a question. I was wondering, due to the resource overexploitation of the Earth, I've heard that a lot of planets in the universe has a lot of materials like gold or silver or iron. And what will happen if we, instead of using those Earth resources, we start using the other planet resources? How would that affect the Earth?
Well, I guess it would be very hard to get the materials from those planets. And so we'd probably first, if we could, try to get them from asteroids in our solar system, right? But yeah, I mean, it would be like having an infinite supply. And so it's not like you have to worry about running out of asteroid material. But what you do have to worry about is like getting your spaceship to the asteroid, drilling that's going to be all that infrastructure. That's going to be the tricky part. But yeah, there's basically an infinite amount of stuff out there. Like you said, we just have to get to it.
Oh, that's great. All right. Thank you.
You're
Have
welcome.
a great
Yeah, good question.
day. Gracias.
Hey there.
Hello. Sorry, I clicked on the dancing. Okay, I'm done dancing.
Hey, I was wondering what would happen if there wasn't any
dark matter? Like if there would be any consequences that we know?
Oh, well, if there never was dark matter, we would not be here. There would be no galaxy, be no stars. Dark matter is kind of important to the whole structure of our universe. If the dark matter were to go away right now, honestly, for you and me, it wouldn't make that much of a difference. But in the scale of, millions of years, the galaxy would fall apart. But we would be okay. We would die before that happened. So.
Okay. It's great to hear that. I have another question. Is there like a method, a device, or something like to detect if dark matter is, I don't know, maybe stronger in some parts? Or is there a way to detect it?
Yeah, so we see it through gravity right now. So dark matter has gravity. And so, yeah, if you have more dark matter closer together, like so denser dark matter, then you have more gravity. And actually, so at the center of the Milky Way, the dark matter is denser than it is out here. And so, yeah, so there's more matter there. So if you were in the center of the galaxy, the gravity from the dark matter would be stronger. That makes sense.
Okay. Yeah. Okay, so the density, it is measured by the gravity, right?
Yes. Yeah.
Okay, thank you.
Yeah, you're welcome. Good questions.
If you were to say something else, please.
Science is awesome. I love being a scientist. So anyway, I guess, yeah.
Okay, thank you so much.
Thank you.
Hi, Andrea.
Hi, thanks for translating, by the way.
You're welcome. Well, I've been hearing you, and I wonder how the perspective of the universe changed when the astronomers discovered the dark matter.
Oh, it just completely changed everything. Yeah, let me try, because actually, so back in the day, the first evidence for dark matter was by a guy named Zwicky, ZWI, something like that. But he was looking at the Coma cluster. So it's this cluster of galaxies, and he was measuring their velocities, and then he was trying to figure out, how much gravity is in the system, and there was needed to be more gravity than he could see. But, even then, now we know it's because they weren't accounting for dark matter. But even, Zwicky, he thought, well, there's, it must be invisible gas or something. And so, but yeah, because then the other thing about dark matter that's crazy is that it's not made up of, protons or electrons or atoms like us. It's made up of something completely different. And so we know that there is, we call it new physics. So there's the physics that make up our bodies and, our world, and we understand that, but then there's this physics out there that we don't really know anything about. And so dark matter was like one of the first pieces to tell us that we're missing a big part of our understanding of physics. There's this stuff out there that we know nothing about. Anyway, so that was, yeah, but so yeah, it changed everything.
Okay,
yeah.
well, thanks.
Okay, yeah, thanks. Hello, hi.
Pero no viene Pónica. ¿Qué le pregunta? Hola.
Hola. Do you have a question?
Queríamos preguntarte, ahora que saben que hay hielo en Marte, ¿se puede colonizar?
Yes, if now that we know that our ice in Mars, we can colonize that planet?
Can we colonize Mars? Not right now. We can't even get people to Mars right now. We're working on that. So once we can get people to Mars, then we can start thinking about colonizing it. But then you could also think, well, maybe to practice Mars, we could try to colonize the moon. But people haven't been to the moon in a long time. So we've got a lot of work to do to make that happen.
Por el momento no, se requiere de mucho trabajo para saber si podría colonizarse Marte, pero podríamos colonizar la Luna.
¿Y qué hay sobre el planeta Kepler?
What about the Kepler planet? Where's your opinion about that?
A Kepler planet. Is that a planet from a different solar system? Are you talking about planets discovered by the Kepler satellite?
No. ¿Planetas descubiertos por el telescopio Kepler?
No, hay un planeta llamado Kepler que es parecido a la Tierra. No sé qué digo.
Well, she asked if we could live in that planet, in Kepler.
Well, so it's named after what's his first name? Johann Kepler. He was an astronomer back in like the 1500s, and he did a lot of work understanding how the planets orbit. He was actually the one to figure out planets don't orbit in circles. They actually are a little bit elongated. They're an ellipse, not a circle. They're a little stretched. So they're just named after Johannes Kepler.
Su labor científica sobre especialmente cómo era la química.
¿Cuál es el planeta más propenso, habitable, más, cómo se explica? ¿Hay algún planeta a que se pueda colonizar y en cuánto tiempo?
Another question is, there is a planet that we can't colonize it?
Well,
like the fastest planets that we could.
Oh, sorry, what was that?
Like the fastest planet that we could colonize, like at the earliest date.
Okay. I think the first thing that we would colonize, if I was planning, would be the moon, actually, not a planet. But then after the moon, Mars. You can't colonize Venus. Venus is just a no-go. It's very dangerous and poisonous gas. You don't want to go to Venus. But the moon, maybe an asteroid. But yeah.
Y después de eso sería Marte o incluso algún asteroide, que por ejemplo Venus es muy peligroso y no se podría colonizar.
Muchas gracias. Hasta luego.
Adiós.
¿Es posible que en otro planeta similar al nuestro se formen seres idénticos a nosotros, o sea, otros seres humanos?
If the planet is technically or probably infinite, is there a possibility that there is a planet where it's like a copy of Earth, and that there are like beings that are exactly as we are?
So we have seen Earth-like planets, actually. We've discovered them. So we know that there are planets out there like Earth. Now, we haven't seen any aliens from those planets, but I think that, So we've seen planets like Earth, but we haven't seen life like us yet. But I think that as far as, life outside of us is almost, is very, very likely. But we don't have evidence for that. But we do find Earth planets.
Is it very likely or not very likely? I didn't understand.
Oh, I think it is very likely that there are aliens. I think, personally.
Perfect. Yeah, we do.
Dice que ella piensa que hay una posibilidad muy alta de que haya personas que sean muy parecidas con nosotros.
All right, thank you.
Gracias. Hello.
Hello.
We're ready. Estela. No, es que no sé inglés. ¿Sí sabe inglés?
Ellas hablan inglés, pero yo sí te puedo ayudar.
Una estrella puede tener en la tiene la mayor tiene el poder de tener una luz tan potente que puede desintegrar un planeta.
¿Que se puede desintegrar un planeta?
His question is if a star has the power specifically of like light that it can destroy a planet.
So the sun won't destroy us. We've got yet. Actually, yes and no. So the sun, for example, as it dies, it's going to get bigger, and eventually it's going to swallow Earth and burn it to ashes. So if the star gets too close to the planet, then the star can destroy the planet.
Puede ser que llegue a absorber algún planeta, porque cuando se van haciendo más viejas las estrellas, tienden a ser más grandes. Que lo mismo podría pasar así como con el Sol y la Tierra, algo que vaya a pasar como mañana o en muchos años. O sea, tienen que pasar muchos años para que llegue a este momento.
También otra pregunta de qué es, por ejemplo, si un planeta desviado de así de planeta solitario, no sé cómo se llama, por nuestra en el sistema solar, en nuestro sistema solar, que pasa cerca de la Tierra y como
Oh no, I might have lost audio. Oh, I can't hear you. Oh wait, there you are.
Can you hear me now?
Yes.
Okay, perfect. He has another question that. Okay, how can I put this? So, he knows about some planets that he thinks that is called like phantom planets that are not exactly part of our galaxy or solar system, but that they can pass near the Earth, for example. His question is that if there is a planet that is like really near to Earth, but like a big mass, can it like make the Earth move its trajectory or like something like that?
Right. Yeah. So I call them rogue planets. Is the phrase I would use. But yeah, so the planets that are just kind of off on their own. Unless it hit directly, if it was a direct hit at the Earth, then yes, it's going to cause a change. But other than that, it would have to be very, very big, very massive to have enough gravity to disturb Earth. Was that the question?
Rogue planets. Entonces, rogue es con G, así que son de los planetas que salen como, literalmente que salen como de lo normal. Ese tipo de planetas, la única manera en la que podrían hacer que la Tierra se salga de su órbita y todo eso, es que literalmente choque con la Tierra o que la masa sea demasiado grande que solamente con
Como la de Júpiter.
Probablemente.
Bye. Thank you. Hi. Hi. How are you?
¿Cómo estás?
Bien.
Dan?
Bien. Bien, gracias.
Bien, gracias.
¿Qué le vas a preguntar?
Ah, no, no, no. ¿Cómo? ¿Cómo?
His question, sorry, her question is, how are stars formed? How are they created or formed?
Well, you start with, say, a bunch of atoms, a bunch of hydrogen, and those atoms all have mass, so they have gravity. So the short answer is gravity. And so the atoms all start to come together. And when they come together, they get hotter and hotter. And eventually it will ignite and become a star if it gets close enough together.
Okay, how would you explain atoms to a kid?
How would I explain atoms to a kid? I guess you could just say that you take a lot of gas. Tell her you take gas, but then you smush it together, and so you use gravity to smush it together. Does that maybe gas is better than atom?
Okay.
Yeah. Okay.
Están compuestos de partículas muy, muy, muy pequeñitas. Y esto hace que con la gravedad se vayan creando las estrellas, se van a formar las partículas y al final is the moon made? Like, how do you make a moon? Or how is the moon created?
So you have Earth when it was really young, and it was a ball, and then an asteroid came and hit the Earth, and it knocked the moon out of the Earth. So does that, yeah, so we had basically, and it was like a Mars-sized asteroid during Earth's formation. It just whacked right into Earth, and it broke off a piece, and that piece became the moon.
So, the moon was part of Mars or the Earth? Okay, perfect. So, básicamente lo que pasó cuando se creó la Luna es que la Luna era parte de la Tierra, pero llegó un asteroide y le pegó a la Tierra. Y eso lo que hizo fue que la Tierra se cortara. Y ese pedacito que salió al espacio se transformó en la Luna.
Sí, soy círculo, más bien quieres saber.
Okay, perfecto. She wants to well, when the moon, like when the asteroid hit the Earth and the moon went to space, how was the circle or like the sphere created?
Right. And the answer to that is gravity. So when something has enough mass, everything keeps pulling in, and it all pulls in the same, and eventually it smooths out and becomes a moon. It's kind of like, you have Play-Doh and you roll it in your hands, it just naturally forms a ball.
Okay, perfect. Thank you. Básicamente, cuando se salió el pedazo de la Tierra y se fue al espacio, lo que pasó es de que por la gravedad se empezó a como amasar, como cuando juegas con un pedazo de plastilina y le vas dando vueltita, así se fue haciendo por la gravedad que había alrededor y adentro.
¿Listo? ¿Listo? ¿Cómo se dice? Fuerte.
Gracias. Adiós.
Given the time of people, the energy is separate. A lot of that comes every one of the things that say that are going to talk about these things.
Why haven't we like gone to Earth? Like, why don't we go anymore?
Like go to the moon?
Yes.
Yeah. It's hard and expensive.
And expensive?
It's expensive, yeah. It costs a lot. Lots of money.
What was the name of the first ship that went to the moon?
Well, so that's, you have to be more specific, but the first mission that had people land on the moon was Apollo 11. But as Apollo 11 implies, there were Apollos before it. But they just didn't have people actually land on the moon. So and so it looks like this first guy was called Luna 1, and it was from the Soviets had a little spacecraft orbit the moon. But Apollo 11 is when they had people on the moon. So there you go.
El Apolo 11 es la primera nave que llegó a la Luna con personas. Antes ya habían ido incluidos constelaciones. How are constellations identified?
Well, I mean, I guess with our eyes, but like, we just made it up. Our ancestors saw pictures and started giving them names, and we still use those names.
Okay. Básicamente con la observación. O sea, viene desde hace muchos años. Y empezaron a darles nombres y a dibujarlas y a compartir esos saberes.
Me quedé con una duda de la niña que hizo la pregunta sobre la estrella. Por lo mismo de los átomos, ¿eso es que las estrellas brillan?
Okay. Why is the reason that stars have light or that they shine?
Right, and it's because the the atoms in the stars interact. Specifically, it's a thing called fusion, and those interactions produce light. So the atoms are smashing together, and that makes light. Yeah.
Perfect, thank you.
Es lo que he escuchado, ¿no?
Sí, es básicamente, o sea, la fusión nuclear, que es básicamente cuando los átomos se juntan y pues van creando calor. Entonces, eso es lo que nos hace.
Bye.
Bye. Thank you. Bye. Don't be shy. Okay. Can always come back.
Okay.
Yeah, it's okay.
Él quiere saber si hay vida extraterrestre.
He wants to know if there is like aliens.
Yeah, probably, but we don't have any evidence yet. But I think there are.
¿Qué minerales diferentes esperan encontrar en el lado?
I don't know one word, but I'm gonna try. Do you know what minerals are?
Oh, yes.
Is-
Yeah, minerals.
Okay, perfect. Okay. So, what type of minerals do you expect to find in the dark side of the moon?
Oh, good question. I would assume the same as the other side of the moon. I think one of the things in it is this thing called helium-3.
Can you repeat that?
I said I'm the minerals. I'm trying to. The one that's coming to mind is a helium-3, but I'm not sure if that's a mineral.
Or like any other type of atomic element?
Yeah, I guess I'm not entirely sure what the moon is made out of. But yeah. Yeah, I don't know. I'm sorry. Lo siento. No
It's
sé
okay
qué
not
sé.
to know. She says, thank you and bye.
Muchas gracias. Adios.
Adiós. You want to interpret then.
Hello.
I want to ask you some more. I'm Has.
Hi, nice to meet you.
Thank you. Nice to meet you too. I'd like to ask you some more generic questions like, who do you think is the greatest scientist to have ever lived?
Ooh. Scientist.
Scientist.
You know, I am actually a big fan of Johann Kepler.
Miss Kepler. Oh my God.
Yeah, and the reason he comes to mind is because there was all this data that the guy before him named Brahe, Tycho Brahe. So Tycho Brahe was this older guy, and he had all this data, and Kepler wanted to go work for him, and Brahe hated Kepler. And he wouldn't let him have his data. And so when Brahe died, Kepler stole the data. And he did some amazing things with it. And so he kind of like, took the initiative. So I'm just glad that he didn't let Brahe being mean to him stop him and like make some huge discoveries for astronomy. So anyway,
Wow.
so I like Kepler. Kepler is cool.
Yes. Yeah, big fan of Kepler, and all that thing about his personal history, how his mom died in a witchcraft trial.
Oh, really? I didn't know that. Wow.
It's really hard, and yes, his personal history is it's astonishingly hard. Yeah.
Yeah.
I have another question. What is the book that you have gifted the most to friends, family, anyone?
Oh, a book?
Yes.
Let's see. Well, it's outdated at this point, but Stephen Hawking's books were really important to me. The Universe in a Nutshell and A Brief History of Time. Let's see. Another book that I personally find interesting, just because I'm also interested in Buddhism, is a book called The Universe in a Single Atom, which talks about things that Buddhist philosophy and physics kind of have in common. They're answering similar questions and how they answer them differently. So if you're looking for something that's a little more philosophical, I would recommend that one. The Dalai Lama wrote it. It's quite good.
Really?
As far as sci-fi goes, Hitchhiker's Guide to the Galaxy all the way, man.
Oh my God, Douglas Adams.
Yes, exactly. Yeah.
What is the meaning of the universe then?
42. But the question is, what's the question?
What is the question, right? We need a 10 million year computer to know that.
And then the question's like, what do you get when you multiply 6 by 8 or something like that?
Yes, it better is not. If you could have, metaphorically speaking, a giant billboard, so millions or maybe billions of people could see it, what would you put on it?
Ooh.
Like a message, it could be like an image or maybe a phrase or.
Well, if it was I would put the deeps what's it called? I'm blanking on this. The Hubble image, they updated it with the James Webb Telescope, the deep field image where it shows all the galaxies. I would do that image and then the words "be kind."
Be kind.
Be kind.
Why?
Why? Someone asks here.
Why be kind or why the galaxies? Because people should be nice.
Yeah, I mean, I agree with that, but why specifically with that image or with the combination of both?
Oh, well, I guess it's well, because the one image they just both, because the one image with all the galaxies, it makes you feel really small, and so it might be easy to think you're insignificant, but you're significant to the people around you, right? And so your actions influence them, and so you're not insignificant. You need to be kind. So anyway, so it might be like, oh, you think you're insignificant and it doesn't matter, but just then I would remind them, like, no, you still need to be nice.
Yes. Yes, I like to call it cosmic insignificance therapy.
Yes, exact. There you go. Yeah, perfect.
What are some movies you recommend?
Ooh. Let's see. So like space movies.
I don't.
Well, as far as a recent movie, I really liked Everything Everywhere All at Once. I don't know.
Yes, it's really. It's Everything Everywhere All at Once.
Everything
Yes, it's
Everywhere
really
All at
good.
Once. Yeah, that one was really good. I was just rewatching with my nephew The Matrix, and I forgot how good that movie is.
Yes. I did rewatch it the other day, and it's really good.
It's really good.
Better than I remembered.
There's a cartoon movie called The Emperor's New Groove. I don't know if you've heard of it. It's a Disney movie about a talking llama. It's hilarious.
Yes. Las frutas del emperador.
I want to ask you something, Andrea.
Yes, go ahead, please.
Is it now that you mentioned movies? It's because I'm a huge movie fan.
Mm-hmm.
How have you watched the movie Interstellar?
I have, yeah.
Okay,
Is that scientifically accurate or not?
So it depends on what part you're talking about. But they did like the simulation of the black hole, gargantuan. Is that what it was called?
Yes.
The visualization of that was correct, and they actually worked with a physicist named Kip Thorne, who just won the Nobel Prize a couple years ago. But they worked with him in order to have depict it correctly. So that was right. But like once you start going inside the black hole, we don't know. And so, they have creative license. They can but they did the movie people wanted to have the characters go faster than the speed of light, and the physicists were very clear. No. Nothing goes faster than the speed of light, so they didn't do that.
Okay.
Yeah, but they also got like time dilation. So you remember they go on that one planet and time is different. That's a physical thing. That's a real thing.
Okay.
So yeah, so they got a lot right, but once you go inside a black hole, no one knows. So you just kind of use your imagination.
And the part that like the multi-dimension part when the dad uses the books to communicate with her daughter, is that possible?
Well, that's the inside the black hole part. So, yeah, it's
that nobody knows.
Exactly.
That's good. I always wanted to know that because I watched this video about a physicist precisely talking about how accurate Interstellar was, because I'm not a scientist. I'm not even close to that. I admire people like you who had the mind to do it, to get to know science, like the core science. But I have never had the mind to do it. But anyway. I mean, I don't know numbers, but I want to know more. That's what I am interested in, movies like that.
Yeah. Well, and it's interesting because I use numbers, but science, at least when you're a researcher, it requires a lot of creativity. It's not just number crunching, because you have to be creative and come up with new ideas. Yeah, so that's one of the things I really like about it is, yeah. So.
Not much about the numbers, but more about the research part.
What was that? Sorry.
Not much about the numbers, but more about research and creative things.
Exactly, yeah.
Very good.
Yeah.
Well, thank you, Andrea.
Oh, you're welcome.
¿O quiere que le pregunte yo? ¿Sí? Ok, venga, porque yo ya pasé.
Hi.
Hola. Hi, ¿cómo te llamas? My name is Priscilla.
Priscilla?
Yes.
Yeah. Hola, me llamo Andrea.
Nice to meet you. ¿Por qué ha temblado en este tiempo más? Priscilla wants to know if there's a reason in particular why we have a lot of earthquakes recently. Do you know something about that?
Oh man, that is outside my area of expertise.
Dice que no es como su área.
No sé.
Well, is it possible? Is it possible that gravitational waves affects the search of earthquakes?
So probably, I mean, I'm pretty sure no. A gravitational wave is such a small thing. Like the way that they oh, sorry, right, you have to translate. Yeah, so gravitational waves are really small and not very strong.
Okay. Él pregunta si las ondas gravitacionales afectaban y por eso puede temblar. Dice que no. Son tan chiquitos que no afectan nada. Así es que no, el espacio no afecta a los temblores. Es interno.
Por ejemplo, ¿hay alguna otra de planeta que hayan descubierto vida como la Tierra? Que tiene antecedentes.
Okay. Also, they want to know if there is a planet that has similar characteristics as Earth in another planet of the universe. Have you discovered that?
Well, I haven't discovered it, but yes, there's lots of them. We've been discovering many planets. They're really, really far away, so we can't really get to them. But yes, there are Earth-like planets, lots of them.
Have you found life on them?
No, unfortunately.
Animales similares sí, pero sin vida.
Sí.
O no hay todavía registro de vida hasta el momento. En otra pregunta ella me dijo que ella creía que personalmente que había vida en otro espacio, pero no hay indicios todavía. Okay. ¿Algo más? ¿Me quieren preguntar? No. Okay, pues ya.
Thank you.
Adios, bye.
Again?
Sí.
Go.
You're back.
Hey, Andrea.
Hello.
Do you believe in God, or are you religious or some kind?
No, I'm an atheist.
You're an atheist. You're not agnostic. You're atheist.
Yep.
Okay.
Yep. Yeah, I was agnostic for a while, but I've thought about it, and yeah, I think I'm more atheist than agnostic.
Why did you decide to dedicate your life to physics?
Well, I always liked science, and when I got to college, the classes got really hard. So I was thinking about, doing something else. But then I started doing research, and so, I tell people that, you in class, you have the answer in the back of the book. Someone's already solved it. You're just learning, what they knew. And research is completely different because you're solving problems and questions that no one's answered yet. And so it requires a certain level of creativity. And I really liked that. And so I struggled through my classes because you have to do the math and you have to learn the scientific principles. You have to know all that. But I fell in love with research when I was in college. Yeah.
What do you research currently?
Oh, I look for signals from dark matter interactions from space, so specifically gamma rays. I look for gamma rays from dark matter. Haven't seen any.
Oh,
Sorry.
So you search for dark matter in the interaction with gamma rays?
Well, I search for dark matter interacting with other dark matter, and then those are producing gamma rays.
Oh, that's your hypothesis.
Yes, that's the hypothesis, is that when two dark matter particles hit each other, they annihilate and create gamma rays. That's the...
Oh, okay. So you think dark matter is a particle?
Yes. That's the best hypothesis we have right now. It might not be real. It might not be true, but it's worth testing. So that's the one we're testing right now.
If it wasn't a particle, what could it be?
That's a good question. So people thought for a while that it was something like black holes that we couldn't see, or really dim planets. And so they were these things called machos, is the kind of term people talked about for that dark matter. But they looked for those because what happens is when you have a really massive thing, light behind it bends, so it's lensed, right? It's a gravitational lensing, and so they looked for these gravitational lensing signals from these potential machos, and they didn't see any, and so we know it's not like just a bunch of black holes that we can't see.
Okay.
So you can go all the way in the other end of the scale and say, okay, well, what if it's a particle?
Okay. So behind light bending, that's what you're saying?
Can you say that one more time, please?
Behind dark matter, there is no light bending, like Venus behind the sun and that stuff.
Oh, there is so it depends on if you're talking about an individual dark matter particle. there's not really going to be any noticeable lensing. But yeah, if you had a big clump of them, actually that's how we can see dark matter from, say, a galaxy cluster. You can see the lensing, and that tells you how much gravity is in that galaxy cluster. And so that tells you how much dark matter is in there.
Okay.
Yeah.
Does super voids in the universe have anything to do with dark matter?
Do the super
Voids? There's
super
like
voids,
void.
yes. Yeah, so okay, when you zoom out, you have galaxy clusters, right? And those are, you can think of that, so those are just like a little, all right, so when you zoom even further out, the universe has, we call them filaments. It kind of looks like a sponge, right? And so like you said, there are these holes, right, where there,
Yes.
but the holes are where there isn't dark matter. So the dark matter is the stuff that's not the holes. I don't know if that makes.
Well, okay.
Because you need the dark matter is where things like galaxies form, because you need to have
Yes.
something to bring them together. And so
Okay.
where there's dark matter, usually there is stars. And
Okay,
right,
see.
and so if there's no stars, if there's a void, it's because there's no dark matter there.
Oh, I see.
Yeah.
I see.
Básicamente,
What is the difference between dark matter and dark energy?
Lots of things are different. Really, the only thing they have in common is that they don't emit light. But dark matter has, gravity, so dark matter pulls things together, and dark energy, we don't know what that is, but it's pushing things apart. So they're kind of, they're almost.
So
like
dark energy is what is expanding the universe?
dark energy is expanding the universe. Yeah. Hello again.
Thank you. And I got an easy question, I think, and is where is the dark matter?
Well, it's going through you right now. It's everywhere.
It's everywhere. Okay. My question is, when a spaceship go close to the sun will suck the spaceship. No? It's a way to say it. And why a spaceship can go through to the space and not get sucked by the this dark energy?
So why don't spaceships get pushed by dark energy?
Yeah.
Yeah. So the dark energy is actually quite weak. In the solar system, the dominant force is gravity. It's just when you start talking about dark energy, you're talking about something that happens over a long period of time, and it's happening like it has a noticeable effect in between galaxies. So it needs to it takes a long time to actually notice it happening, and it takes a lot of it, so you have to kind of zoom out. So if you're zoomed into the solar system, you're zoomed into a rocket ship, the dominant thing that it's going to care about is gravity, not dark energy.
Okay.
I don't know if that makes sense. Yeah.
See.
Hello.
Do you have a favorite theory of everything?
Favorite theory of gravity? Well, I mean, Newtonian gravity is doing a really good job. And I guess, I don't really know too many theories of gravity. I know that, so we have
Theories of everything are the same thing as theories of gravity?
so the theory of everything is trying to describe gravity, but on really small scales.
Quantum scale.
Yeah, so saying, if I'm talking about an atom, how do I understand gravity on the size of an atom, and that's something. So we can understand gravity, when we zoom all the way out at like planets. That makes sense. And then you can use particle physics to understand particles and atoms and things like that. And then being able to do both at the same time, you can't do that yet. No one that would be the theory of everything, being able to do gravity and particle physics with the same theory. And we don't have that yet. So if you come up with it, you'll get a Nobel Prize.
Yes, so true. Thank you so much for everything, Andrea.
Oh, no problem. Happy to be here. Been getting some really good questions. I like the hip hop dance. Oh, hi. I'm supposed to say hi. Hello.
Are you dancing for real, or is just the avatar?
It's just the avatar. No, I'm not a good dancer. You don't want to see me dance.
I was like, she's a scientist and she's also a dancer. Wow.
No, I'm not that cool.
Mira, señor, porque no sé.
Sí, no hay problema. Yo te ayudo.
¿Qué es? Hola.
Hola.
Que si un cohete o alguna persona puede sobrevivir a alguna, como por ejemplo un agujero negro o algo así, que sí puede sobrevivir.
Okay. Her question is there a possibility that a ship can survive a black hole?
Oh, yeah, I think so. So it kind of depends on if you're asking the people in the ship or if you're asking the people watching the ship. And so I think if you're in the ship, even if you cross the event horizon, I don't know, you might get stretched like spaghetti and die. We don't know. We've never done it before, but if you're on the ship, it might be okay. Actually.
Okay. Básicamente dice que nunca se ha hecho, pero que tal vez pueda haber una posibilidad de que si estás en la nave lo puedas hacer, pero que si estás fuera de la nave, tal vez el hoyo negro te absorba y te haga como un espagueti y fuera.
Okay.
But yeah, it does have a lot of gravity, and so you'd have to figure out how to not get crushed. But if you had a really good spaceship, maybe. Yeah.
Okay.
Yeah.
Thank you.
You're welcome. Bye.
Yo te acompaño. Ya se puso a bailar.
Hi. How are you?
¿Cómo estás?
Accelerator called the LOC, chanting products 27 kilometers an hour. Four closely along that accelerator, we really times 3 seconds.
Más afuera de los agujeros negros.
How strong are black holes? Did I get that right?
Yeah, wait. ¿Te refieres como fuera, o sea, qué es lo que hay alrededor de los agujeros negros?
Cuando pasas, ¿qué hay allá?
Sí. Okay. What do you think is there when you go through a black hole?
Oh, we don't know. I think that one theory is that it's a wormhole and you come out another black hole. But we haven't seen those. So yeah, I don't know. Maybe a wormhole?
Dicen que hay, bueno, que hay
¿Qué me estabas diciendo? ¿Historia?
cierto que Galileo Galilei descubrió que la gente decía que el sol estaba donde estaba la Tierra y la Tierra estaba donde estaba el sol?
Is it true that Galileo Galilei discovered that the Earth wasn't the one that
Yeah.
exactly.
Yeah, so Galileo, he discovered that small things orbit around big things. And the way he discovered that is by looking at moons of Jupiter. So he looked at Jupiter and he saw these little spots that were Jupiter's moons, and he saw them going around Jupiter. And so that made him say, okay, well, this theory from this other guy, Copernicus, is saying that Earth goes around the sun. Well, Earth is smaller than the sun. And so if Earth is and the sun are like Jupiter and its moons, then Earth has to go around the sun.
Galileo Galilei lo que descubrió es de que hay cosas pequeñas que orbitan alrededor de la eso le hizo pensar, bueno, si esto es lo que está pasando, entonces tal vez en nuestro sistema solar
Bueno, en su época la gente creía que el sol estaba en la Tierra y la Tierra en el sol. Bueno, sí, donde estaba. Pero por medio de los telescopios que él inventó, descubrió que no era cierto.
descubrió que los pequeños orbitaban y eso le hizo pensar que entonces
¿Posible que exista vida extraterrestre en el espacio?
Is there a possibility that, yeah.
Probably, but we haven't seen any yet.
Ok, probablemente, pero no se ha confirmado nada y nunca han visto. Ella me ha dicho que personalmente ella cree que sí puede haber, pero no hay ningún indicio todavía sobre eso.
Now, another thing that's part of that is that it'll be very hard, if we find aliens, it'll be hard to talk to them because nothing travels faster than the speed of light. And for example, the closest star is 4 light years away. So if there were aliens there, it would take 4 years for our signal to get there, and then 4 years for their signal to get to us. And that's just the closest star. Most things are thousands, 10,000, millions of light years away. And so I think there are aliens, but I'm not sure if we're going to be able to talk to them.
Dice que incluso si hay, sería muy difícil comunicarse con ellos porque por el tiempo en que tarda en viajar el sonido y la luz a través del espacio. Por ejemplo, la estrella más cercana está a 4 años luz, lo cual quiere decir que nos tardaría, para enviar un mensaje se tardaría 4 años en llegar, y para recibir un mensaje 4 años en recibir, y es nada más en la estrella más cercana. Entonces lo mismo pasa con planetas que están mucho más lejos, estrellas que están mucho más lejos, es el tiempo que nos tardaríamos en recibir y enviar.
Como la de Lightyear, ¿no?
She says that is it something like in the Lightyear movie?
Oh, I
Something
haven't
like that.
seen the Lightyear movie.
Yeah.
Oh, like the Buzz Lightyear movie. Yes, yeah. He's named after the Lightyear. Yeah, Lightyear is it tells you it's a distance, right? It's like a kilometer or a mile or some unit of distance. But yeah, they named Buzz Lightyear after that.
Amazing! I didn't know that.
Yeah, and Buzz I think is from Buzz Aldrin, who was the second man on the moon.
Oh my God, that makes sense. Okay. Dice que sí, básicamente que sí. Y como fun fact, es posible que a Buzz Lightyear lo hayan nombrado así por uno de los primeros hombres que caminaron en la luna. ¿Por la luna o más de que no sé. Algo así.
Gracias.
De nada. Adiós. Hello.
Preguntar de los agujeros negros, de cuál es su similitud entre la teoría de los agujeros de gusano y los de agujeros negros.
Okay. What is the similarities or like the things that are the same between the theory of black holes and the wormholes? I think you said something like that.
Okay.
The terms.
Yeah, so right, black holes they warp, they distort, they bend space-time. And the idea is with a wormhole is that you can have two black holes bend such that they start to touch and they form a connection. And so that's what they call a wormhole. And so, yeah, I guess a wormhole would be made up of two black holes. We have not seen wormholes. We've only seen black holes, but that's how they're connected.
Okay, basically, if I remember correctly, like the theory of wormholes is that one part or one side is the one that like sucks you in, and it's spits you out. I don't know how to.
Yeah. I think that's the theory. Yeah.
Okay, perfect. Básicamente, la conexión es que, ¿cómo me habías dicho? Los de gusano. Esos son dos agujeros negros conectados. Es una teoría, nunca se han visto y no se saben si existen realmente. Solamente han visto hoyos negros, pero la teoría de los gusanos es que de un lado es como teletransportación, de un lado te chupa y del otro lado te saca, básicamente.
Y quería saber de eso mismo, de la teoría de que los agujeros negros succionan y los agujeros blancos se expulsan, de que si, ¿cómo sería la teoría de los agujeros blancos?
O sea, la teoría de los agujeros blancos así, si han visto algo así o
sí, cómo funciona según la teoría.
Okay. He's asking about white holes. Yeah. Basically, like, how do they work?
Well, we haven't seen one yet, so I don't even know if they exist.
No han visto ninguno, entonces no saben ni siquiera cómo existen. Perdón, no saben si existen, entonces no saben cómo funcionan.
Sí, y la última pregunta era, ¿es difícil estudiar astrofísica y es fácil de entender?
Is it difficult to understand and study astrophysics?
I mean, yeah, it's challenging, but I work with a lot of very smart people in a team, so you're not alone. And you know, some people know things that I don't, and I know things that they don't, and so you know, we all kind of work together. So none of us are, you know, we're not Einstein. Most of us, you know, I'm not Einstein, and so you know, I'm not that smart, but when we work together, we can get some pretty cool things done.
Okay, perfect. Básicamente dice que hay procesos que hay cosas que son difíciles de superar, pero lo padre es de que siempre hay personas generalmente cuando trabajas en equipos de campo y tal vez puedes llegar a saber cosas que otras personas no saben y esas personas pueden saber cosas que no saben. Entonces siempre es como una comunidad de ideas y es lo padre. O sea, que ninguno de ellos son Einstein, pero juntos pueden hacer cosas padres.
Yeah. Gracias.
Okay.
Gracias.
Bye. Thank you. Hello.
Hola,
How are you?
bien, aquí andamos. O sea, sí lo entiendo, pero no lo hago. Y la pregunta es si hay prueba suficiente de que haya vida en otro planeta además de la Tierra.
I was gonna say you already know my answer. Yeah. So, right. Are there aliens? Right. That was the question.
Yes. Yeah, but basically like in another planet that is like Earth. Yeah.
Okay, yeah. So there are planets like Earth. We've discovered them. And we haven't seen or gotten any signals from life on those planets. So anyway, but I'm pretty sure there's life out there, but it's going to be really hard to communicate with it, right? Because everything's so far away and nothing travels faster than light.
So there are probably like, if there is life, we're probably like already getting a message, but we haven't received it yet, right?
Yeah, maybe it hasn't gotten here yet. Yeah.
Okay. ¿Entendí un poquito o tú sé que le...
No, algo le entendí, sí, pero no.
Básicamente, no se ha comprobado nada de que haya vida en otros lados, pero personalmente ella cree que sí hay. También es muy difícil saberlo por la comunicación, más que nada, porque por el tiempo que tarda en viajar tanto la luz como el sonido, se tardaría mismos años en ir un mensaje como en regresar. Entonces, por eso es como muy difícil la comunicación si hay ese tipo de cosas, pero lo que yo le pregunté es que entonces probablemente hay alguien, si hay vida o algo así, ya nos están tratando de comunicar, ya vino el mensaje, solamente lo he tal vez.
Otra pregunta. ¿Cuál es el origen de la vida aquí en la Tierra?
what is the origin of life in Earth, or like the beginning of life in Earth?
That's a good question. I mean, so there's a lot of theories, and I think that it does get into some philosophy. But right, like one theory I've heard. So I guess the short answer is we don't know. But like, did a meteor crash into the ocean in the early Earth and have bacteria on it or something that ended up evolving into the life that we see today? But I think that could be it. But we don't know. It's a really interesting question. Yeah.
Basically, the beginning of life in Earth comes from the stars, right? Like,
that's
there's
a good
like
point. Yeah, right. Right. There was a star before our sun. Actually, our sun is the second star where it is, and that other one, made all of the atoms that make up you and me. So yeah, exactly. It went supernova and made heavy metals. So no, that's a great answer. Yeah.
Básicamente, no sabemos. Desde un punto de es como se cree que viene de las estrellas por medio de un asteroide que llegó a la Tierra y se fue en el mar y traía bacterias y de ahí se...
Se contrapone lo que dice la Biblia.
His question is there like a juxtaposition between what the Bible says about the beginning of life in Earth, or like the origin of the universe, between what the science is about it?
I would say it depends on how literal you are. It depends on how literal you are with the interpretation, right? If you literally interpret the Bible, then it says Earth is only what, like 10,000 years old, 2,000 years old, and that is not true. Earth is much older than that. But if you didn't interpret it as literally, I don't think that science disproves religion, if that makes sense. But yes, but the Earth is definitely more than 2,000 years old. I don't know if that was a question.
Okay, perfect. Yeah. Dice básicamente que depende de lo literal que tomes la interpretación. Millones de años antes de menos, y en realidad ya existiendo. Entonces, básicamente
en relación con el cuerpo humano, la escritura, la Biblia dice que el polvo fue tomado y se le sopló la vida. Científicamente comprobado, nuestro cuerpo tiene todos los elementos de la Tierra. Entonces, ¿no eso es una prueba?
Te va a dar la misma respuesta. Okay, so the Bible says that that the body is composed of ashes, and it was created like the combinations between ashes and the wind. And he's asking if science can like says the same thing about it. I know that in biology we like theoretically we see that the body is composed of all the same elements, and as the earth does, so it makes a little bit of sense, but it was like a professional opinion.
Oh, my professional opinion. Yeah, so I think that you know, right, because the people who wrote the Bible, you know, didn't have the scientific understanding we do today, right? And so, yeah, when you talk about ashes, like, yeah, the human body is made out of carbon. So like you were saying, you know, so maybe, you know, back then they didn't know what carbon was, so they called it ashes. And you know, you talk about wind. Well, you know, we breathe in the air, and the air's in our lungs, so it's part of our body, and then those gases get absorbed by our cells. And so I think that, you know, the ashes in the air could just be a way of describing the same thing scientists do, just with different words. You know?
Yeah, okay. Dice del sentido literal que le tomes también, pero que sí, o sea, tal vez en ese momento no tenían el conocimiento científico necesario para llamar al carbón el polvo con sí, pero básicamente el principio es el mismo.
Horas difíciles. Se quedan sin respuesta. Gracias.
Gracias. Adiós. Hello, come on up. Hi.
She wants to ask if you have worked or if you work in NASA.
I actually worked on a satellite called. So the short answer is yes. I have worked on a satellite. It's called Fermi. It's still going. So yeah. So I work with people in NASA, and I used to work on an experiment in space called Fermi, which is a NASA experiment.
Is it Fermi? With
yeah,
F?
Fermi. Yeah, it's named after Enrico Fermi. He was a physicist, but yeah, it's called the Fermi Gamma Ray Space Telescope.
Okay, perfect. Sí, de hecho está ahorita trabajando en un proyecto con personas de la NASA y en un proyecto que es un satélite que se llama Fermi. Fermi. Y, sí, Fermi. He wants to speak in English, was it?
Okay.
Hola.
Hola, ¿cómo está? Hi, how are you? Oh, can you say that one more time? You have to say it right into the microphone.
Tienes que decirlo aquí.
Hi, finding you.
I'm sorry, I didn't get
fine.
it.
And you?
Huh?
I'm fine, and you?
Oh, perfect. I am good. Thank you for asking.
Thank you.
You're welcome.
Bye.
Bye. Nice to meet you.
Now I have a question.
Oh, okay.
Well, it's not really a question. I want to have a conversation while we have time because there's no one here.
Unless you want to have a break, of course.
No, I'm doing good.
I saw a TikTok like 2 weeks ago that I have not been able to stop thinking about it. It was about what the Bible says about the like when Jesus was born or something like that. I have not read the Bible, but they were putting like the phrases and everything, and it basically said things that were kind of how to put it like.
You okay?
Yeah. Basically, like how the universe was created, or how what was happening on Earth on the day that Jesus was born. So basically, the Bible said something about and some planets aligning, and like the star and everything, and three other stuff that are basically the alliance, the aligning of the stars or the planets were exactly what happened on that day. The three other things were the magicians, or like
Magi. The wise men.
yeah,
yeah, we call them the wise men.
okay, and the star was there because like everything was happening. Yeah. And it was the beginning of a new era or something, and so it's basic. And I have not been able to stop thinking about that, and I wanted to share that with you and see what you think about that.
So I have a bunch of thoughts on that. One of them is so say you're looking at the constellation Orion, right? You know Orion, the hunter, he looks like a big H. And you know, his shoulder has a star called Betelgeuse that's going to go supernova soon. So that's why I think of Orion. But Orion, you know, moves across the sky. Right, he rises, he sets. He's not in the same location in the sky. He's not like the North Star, Polaris, is aligned with the Earth's pole, so it doesn't move. So when you like try to figure out which way is north and you use the North Star, that's good. But you know, that's fine, it doesn't move. But if you're talking about a supernova that's in, say, Orion, it's going to move through the sky. So you'll be going one direction, and then an hour later you're going to follow it and you're going to go another direction, and then an hour later it's going to be in a different direction. And so I'm not entirely sure how that is. So unless the supernova was north, but I think they were actually traveling west. So anyway, so that's a problem number one in asking, did that really happen? But you know, there might have been, there are things that get bright in the sky, and maybe, you know, a lot of times the stuff in the Bible that seems like it can't be real, like the flood, right? Noah's flood is, I think there's some evidence that they are rooted in truth a little bit. Like, you know, so like it might not have been a supernova that actually guided them, but maybe around that time, a supernova did go off and people were like, oh, there's this bright thing in the sky, I bet it could have done this. And so but yeah, like with the flood, I think maybe there was, you know, a small flood, not the whole earth getting flooded, but that story kind of got passed down and ended up getting kind of
folklore.
Yeah, exactly. Yeah. It just got a little more embellished. I'll say that. Yeah, actually, fun thing about the flood is that there's this book about Gilgamesh, and that also talks about a flood. So there are multiple things that talk about floods, actually, from a long, long, long time ago. So that's kind of cool. Okay, yeah, so that's thought number one, is that supernova would move through the sky, so it would be really hard to use them as a guide. But supernova have happened in the past, and so it's not like people are crazy about saying that there's bright things in the sky. The other thing is, I think that my thoughts are that Jesus was not actually born in December, right? And so if you're going to start talking about like the alignment of planets and stuff, are you talking about the alignment of planets in December of that year? Or because that's going to be different than if he was actually born in April, you know? Like, so, you know, that there's a source of ambiguity there as to what exact day he was born. Anyway, those are my thoughts.
Basically, what I found like interesting about it is that what they are saying is basically that everything that the Bible says, at least of that moment, is a personification of like what happened in the solar system at that moment, or what they were seeing in the stars. So it was like, what other things are there that we can explain from in the Bible based on things that happened in that moment? And so it's like, yeah, it made me think about it a lot.
Right. Yeah, it's interesting because, yeah, like oh, I'm sorry, is there someone there who has a question? I don't need to. I don't bite. Hi.
What is black matter?
Dark matter is what holds our galaxy together through its gravity.
Can you repeat that,
Oh,
please?
yeah. Dark matter is what's holding our galaxy together with its gravity. But it doesn't have any light.
Okay. Es lo que en nuestra galaxia llamaríamos gravedad, pero no tiene nada de luz.
O sea, no tiene como un vacío. ¿O qué?
Es como, sí, it's like a void.
No, it's more because there is something there. It's just invisible.
Hay algo ahí, pero no es visible con los materiales que tienen en el momento. Entonces no sabe exactamente.
¿Qué tan avanzados tienen los estudios?
How advanced or how advanced are the instruments, or have you discovered something that can help you understand better the dark matter?
Well, we are looking for, so we can see it interact through gravity, and we're looking for it to interact in other ways. And so far, we haven't seen anything, which is a bummer. But we're going to keep looking because our instruments keep getting more and more sensitive, and so we even have a plan for the next 10 years of instruments we want to build to do even better job than what we have right now. So we're gonna keep working.
Okay. Básicamente con los instrumentos que tienen ahorita no han podido encontrar algo. Están siempre trabajando en desarrollar mejores instrumentos más sensibles a las cosas. Pero
Puede que ellos tengan como evidencias congruentes o como el hecho.
Okay. So is there like a connection that we can find between dark matter and aliens, basically?
Que salga como
Or
insistir en el tema.
Is there wait, ¿te refieres como hay algo que como un detonador que les
como actividades, mensajes o más materia diferente o partículas que les lleven a investigar esa misma tarea, por así decirlo.
Basically, what he wants to know is not exactly like that, but he wants to know if there is something about dark matter that is interesting enough to keep looking, like to understand it or to see what's in there.
Right. So an interesting thing about dark matter is that it's we call it like it's a fundamental particle. It's like a proton. So, you know, you're asking about maybe a connection with aliens. The dark matter that we have here on Earth is exactly the same dark matter that they have on other planets. So the dark matter is throughout the universe, and it's like an atom, right? An atom of hydrogen is the same here as it is further away. And so we're talking about, you know, a fundamental, a basic building block, piece of the universe, and we don't understand it. And so it's responsible for how galaxies form and come together. It's like, you know, deeply rooted in why we're here and why are we alive. And so that's why I think it's an interesting thing to study. Anyway.
Básicamente es una partícula más. Y es una partícula y es igual de importante que las otras. Y eso cuando siguen estudiando las otras, tienen como esa partícula hermana que no se entiende, por eso es importante seguir viendo porque tienes que ver cómo va a afectar como a las otras cosas en general.
Exacto, ok. Y dentro de está el éter y el carbón, dentro de la materia. O sea, dentro de la materia oscura están como en diferentes opciones el éter y el carbón, que son como otras sustancias.
Is there like the substances or like ether or like matter ether or carbon inside or like in the black holes or dark matter?
Dark matter de sustancia negra.
¿Te referías a la materia oscura o
al éter y al carbono? ¿Cómo?
Pero te referías a que el carbón y el éter que estaban en los hoyos negros o
va dentro del desarrollo de la tarea de la investigación, pues de la materia oscura, pues. Y va dentro, ¿no? Sí, a eso te refieres, porque
not inside dark holes, but inside dark matter. Like, is there anything that suggests that there is like ether or carbon in it?
So I guess when you talk about inside dark matter, at least the theory is that it's just a particle. So it's like asking what's inside an electron. Like there is nothing inside an electron. There is no inside of an electron. And so but yeah, so dark matter, at least the theory that I'm investigating is that it's a fundamental particle, and so it's just the dark matter. There's nothing smaller. I mean, it might be made of like components like oh gosh, what are they called? Like a Higgs xeno or something. They have like they do have little pieces, but it's basically a fundamental particle. If that makes sense. At least that's what we think. Yeah, we don't know that for sure.
Okay. Ella en el está investigando de la materia en sus teorías, pues, de su equipo, es que es una partícula.
Humans are killing the action. We actually have nerve microwaves in our bodies that human cells. And now that we're considering to actually go to these places in the long term, we need to make more considerations for the future of the human treatment. You need to think What's the right thing to do? You have to get what's the safe thing to do, the scientifically sound
No,
first.
pues muy interesante el tema y éxito en sus tareas. Chica, thank you, sir.
Thank you.
He says that thank you so much and like good luck with everything that you're doing.
Oh, that's sweet. Thank you.
¿Alguien más que quiera preguntar?
Sí, pero es que
Hello.
¿Sabe cómo qué es lo que pasa? Sí, o sea, entiendo que es como lo que mencioné que era como la gravedad, pero en sí ¿cómo la podríamos definir? O sea, ¿son los agujeros negros de lo que se está hablando o no?
Puedes preguntarle de cualquiera que tú quieras, o sea, cualquier cosa que tú quieras. ¿Tienes esa pregunta específicamente de los agujeros negros?
No, bueno, más bien quería saber cómo, si no existiera o cómo se dieron cuenta que existe la materia negra, o si no existiera, ¿qué pasaría con el universo, la Tierra? Sí.
So basically, how did you discover that the dark matter was like existed and was there? And what will happen if the dark matter didn't exist?
So the first evidence for dark matter actually came about, I think it was 1934. It was in the 1939, by a guy named Fitz Zwicky. Is a Swiss astrophysicist, and he was looking at galaxies in this thing called the Coma Cluster. And he saw the galaxies were whipping around really fast, and he calculated how much gravity you needed in order to keep them together, and you needed more gravity than you could account for. Like, you needed more gravity than just what the stars were giving. And so that was the first evidence. Okay, I'm gonna pause.
Okay. Básicamente, empezó por un astrofísico en 1939 o 1934, no se acuerdo muy bien, que estaba buscando unos planetas en cierto plano con el telescopio de Sol. Y se dio cuenta que los planetas estaban viajando mucho más rápido de lo que deberían, lo cual significa que la gravedad tendría que ser más alta. Pero cuando hizo el cálculo de la gravedad que se necesitaba, era demasiada. Entonces ahí se dieron cuenta que había algo más. Y es como se empezó se descubrió la materia, la materia oscura.
Y bueno, que también como que pasaría si si nosotros nos acercáramos como a un agujero negro o algo así. Y también como qué sintió ella cuando vio la primera imagen del agujero negro.
Okay. So, do you remember the second part of the first question?
Yeah, what would happen if there was no dark matter? Right?
Okay.
Yeah.
Yeah.
And so if there never was dark matter, there wouldn't be any galaxies, there wouldn't be us. But if dark matter were to suddenly disappear, it really wouldn't affect us that much. The galaxy would fall apart, but it would take millions of years for it to fall apart. And so we would be dead before it actually did anything that we would notice.
I guess that is because it's like a fundamental particle, right?
Yeah.
Okay. Básicamente, si no hubiera materia negra, materia oscura, el universo dejaría de existir. O sea, nosotros no podríamos existir sin la materia oscura, pero si ahorita en este momento la materia oscura fuera a desaparecer, nosotros no lo notaríamos porque tardaría el universo años en acomodarse en eso y como en desaparecer. Y me acuerdo que me habías hecho 3 preguntas que quería que te contestara.
Okay. Sí, lo de qué sintió ella cuando vio la primera imagen del agujero negro.
¿Qué? Le pregunté eso y después la otra. Okay. What did you feel when you saw the first like black hole image?
Oh, just awesome. amazing. I also felt really, I don't know, it's cheesy, but proud of human beings, for being able to accomplish something so amazing. Anyway.
Okay. Básicamente que se sintió muy orgullosa de la humanidad por haber hecho ese logro. Y genial. ¿Y cuál era? No, ya se me olvidó. Thank you so much.
Thank you.
Hola.
Hola.
Hi. ¿Le puedo preguntar yo? So I'm really curious about like if there's any relation between like human composition and the dark matter in humans and cosmos. Like if there's like actually like a cosmos inside a human. Do you know what I mean?
Well, I guess one thing about dark matter is that it's something completely different from the matter that makes up our bodies. And so, right, we're made out of these atoms and hydrogen and carbon and all these little building blocks. And dark matter is something completely different. And so, but let's see. And so, okay, well, I'm sorry, what was the second part of the question? So, yeah, so dark matter is something completely different from normal matter. And then you were asking if there was a connection between, or if there was like a universe inside our bodies, or, sorry.
Yeah, technically, like I've heard like there's an universe inside of us and we have like like a cosmos. I don't know if that's really like something poetic or if that's like really true, you know what I mean?
Well,
like real.
Well, it's so I don't know if there's like a whole universe inside us, so to speak, like in a literal sense. There is some poetic beauty in astrophysics. For example, like all of the atoms that make up you and me were once inside a star. And so we're all connected because we all kind of came out of the same star. We all came out of the same Big Bang. The Big Bang, all the atoms were made then. So I don't know. I think that's beautiful, personally, that we're made out of stars, or we're made from stars. I don't know if that answers your question. Sorry if I don't understand.
No, it does. Thank you. I was just like curious about like if that was like true or I mean I know what you're saying. Like we also have atoms and we have composition of that, but yeah, I was just wondering if there's just black matter inside of us. But I think you already answered that, so thank you.
Okay, great.
Thank you.
You're welcome. All right, thanks. Nice to meet you.
Hi again.
You're back.
Yes, I'm back. I wanted to ask you, what does it take to be a physicist? Because I always wanted to do science, but I'm not particularly good at math, so I ended up studying arts.
Well, I guess if you want to do what I'm doing, you do need a PhD in physics. But I don't think that what I'm doing is the only thing that you can do that's related to science. Like what you're doing right now, doing outreach, like, we need science enthusiasts, right? We need fans of science who aren't actually scientists. And I think that, and yeah, so like the stuff that Agnes is doing, combining art with science and then sharing it with people, that's so important. And I'm really glad she's doing it. And, and so it's like, yeah, I'm over here playing around on my computer and trying to find dark matter or whatever, but like bringing it out into the public's so important. And so you don't need a PhD to do that. So
Yes, you're right.
yeah.
And I completely agree. It's awesome to see it and to be part of it. I also wanted to ask you if you've discovered some, well, you obviously have, but what have you discovered, or what is the most impressive thing you have discovered in your research?
So what I specialize in and am known for in the field is being very critical of potential signals. So it's like you know, we've been looking for dark matter, and people will go in the data and they won't do their math right, and they will think they see dark matter, but they're not doing the statistics right, and so it's kind of like, you know, they think they saw a ghost, and what I do is I say, no, that wasn't a ghost, that was just a cat. And so it's kind of like what I've done in my career that's been the most impactful. I haven't discovered anything, but I've told people like, no, that's not a ghost, it's a cat. Go look again, it's just a cat. And cause like, but it's interesting because, you know, dark matter is such an important topic now that if someone were to find a dark matter signal conclusively, that would be huge. That would be Nobel Prize. And so like, you know, you can imagine that's why a lot of people, you know, think they're seeing ghosts, because if they see a ghost, they get a Nobel Prize. And so that's, you know, and I think that makes them see ghosts where there aren't ghosts. And so you need to have people who are like, okay, guys, let's take a step back. Let's take a closer look. And so whenever I've taken closer looks at these claims of dark matter, I have killed them and shot them down. So because people can't do their math right. They gotta do their statistics right, man. It's not hard.
That is so important.
Yeah.
Thank you for being here and for answering all our questions.
Bye. I think that's my favorite dance.
Professional dancer now. Please practice.
John did more dances for you.
Yeah, I only have 3 dance options. That's one. You saw the hip.
That one is like the chicken.
Chicken dance. Yeah, exactly.
Yeah.
Yeah.
Here again.
Hey, welcome back. Sorry, zoomed in.
Thank you. Well, I just saw something today, and I was wondering if you know about the Planck length.
Yep.
What is it? Because I didn't understand it. I didn't understand the explanation. And why is it the smallest way to measure something?
Right. It is so. I'm sorry. I'm trying to think of a way to explain.
Because I read it said like, well, I didn't understand it enough, I think, but that the universe wouldn't make sense in something smaller. It's like the smallest possible, something like in that way.
Yeah, it's the smallest unit, and so so it is. It's really really small. So the first thing that pops in my head about Planck length is that the Planck length is a fundamental thing that comes out of physics, and so you think about our units of measuring, you think about like meters or miles, like all of those are kind of arbitrary and they're very human specific. And in the book Contact by Carl Sagan, the aliens send us a signal and tell us how to build a machine, right? To do a wormhole or whatever. And so they come to the engineers and they have the designs and they're like, well, how did the aliens know how big a meter is? And he's like, oh, they didn't give it to us in meters. They gave it to us in Planck lengths, because that's fundamental. That the Planck length is the same for aliens, no matter what their math is. Just they live in the same physical universe as we do, and so it has to be the same. So that's kind of one of the first things that pops up to my head when I think of Planck length. But yeah, you also think, and I honestly, I'm not sure if this has too much to do with it, but there is the uncertainty principle. Do you know about that?
What?
The uncertainty principle, Heisenberg?
No, I don't.
No. Okay, so it's interesting because Heisenberg showed that in quantum mechanics you can measure, say, where something is, and you can measure how fast it is. And if you were to try to do those measurements perfectly, you can't know perfectly the position and the velocity at the same time.
All right.
And it's just like that information does not exist. No matter how perfect your measurement is, you cannot know both of those at the same time. So there's like a certain
No, sorry.
I was just gonna say that there's a when you get really precise and you zoom really far in, there just is a fundamental resolution to the universe. You can't go smaller. And it comes out of quantum mechanics, and it's really weird. You would think, oh, I could just get smaller and smaller and smaller, but no,
And you're pretty, like, physicists in general are pretty sure that's the smallest unit, or is there a possibility we will discover something else in the future?
What was the first part? Sorry, I missed it.
If you are sure that that's the smallest unit, or is it just like sure for now, but maybe we'll discover something in the future?
Well, I mean, never say never. But the Planck length comes out of the math just by itself. So it's because we can make our telescopes or our microscopes better and better and better, but the Planck length doesn't care about that. It's
math. It's
math. Yeah, exactly.
That makes sense. Thank you very much.
Oh, you're welcome. Yeah.
Various kinds of resources and material deposits to the surface.
Could you discover a fundamental particle if it's smaller than a photon, like smaller than light?
So, is light a point particle? Right, because you ask yourself, like, smaller than light, and so how big is light? And I think that light is like an electron, where we call it a point particle, and so it doesn't have a radius. It doesn't have a diameter. It's as small as possible, and so.
Oh, all right. Like well, the question actually was a photon. but
Que si,
ajá,
si es más pequeña que un fotón, quiere decir que no puedes verlo.
ajá,
La luz no puede rebotar en la
ajá, pues no quiero. Well, I'm kind of communicating here, but the thing is that if a photon is well, if an elemental particle is smaller than a photon, it wouldn't reflect light, or how could you see it?
Right. Yes, that's really good point. Like for example, if you're looking with your eyes through a microscope, yeah, visible light. So when you're going to talk about the size of a photon, you're going to talk about its wavelength is the size. And so right, you go to smaller wavelengths and that's higher energies. And so, we can use visible light which has a certain wavelength to see like cells and stuff. But if we want to go even smaller, like he was saying, you need to go to smaller and smaller wavelengths. And so then there gets to be the point where the light, it's just you can't make it. You just can't make a light telescope at those wavelengths. And so in order to get even smaller, instead of using light, instead of using photons, you use electrons, because like I was saying, an electron is also a point particle, and so that's an electron scanning microscope. I don't know if you've seen images from one, but those can get, see really, really small things because they're using an electron as opposed to a photon.
All right, and what equipment do you use to study electrons?
Oh gosh, a bunch of different kinds of things. Vacuum chambers, wires. I don't know.
No, me neither.
Yeah, I don't know. I've never worked on a scanning electron microscope, so I don't know what they're made out of.
Oh, they have like electron microscope.
Yep, they have electron microscopes. Yep.
Especially, wow. I'm gonna make them research. Thank you very much.
Oh, no problem. Hi again.
But how could you find a fundamental particle smaller than an electron or?
There is none. An electron's as small as you can get. There are other things as small as an electron, but
Okay.
yeah.
Yeah, but quarks are bigger than electrons. I just
No,
read
quarks
this.
are also fun. Quarks are also point particles, I believe. They're the same size.
Yeah?
They're as small as you get. Yeah.
Lo acabo de googlear y pues. Ok. No, pues dice que no hay nada más chiquito que. ¿Eh? Ya no sé. Thank you.
Ni eres de tanto de ciencia, más bien de dónde vive. Hello.
Hi.
Why do you study in New Mexico? Is about the land, or is something about the land?
Well, I guess I'm in New Mexico because that's where we have a laboratory called Los Alamos, and that has all the people who are also studying this, and so I can be part of that team. But yeah, I've actually been studying dark matter for 12 years. And I've studied it in Houston, Texas, and I've studied it in Columbus, Ohio, and I've studied it in San Francisco, and now I'm doing it in Los Alamos. So a lot of the instruments, you can just get the data over the internet and then do your data analysis. So you don't have to be at a specific location. The lab here is funded in the United States by what's called the Department of Energy. And so they're really interested in dark matter, and so there's money. That's why there are people at this lab working on dark matter because it's funded by the Department of Energy. But I have colleagues from all over the world, even from UNAM. So get some of my Mexican colleagues, Europe, Japan, yeah, they're from all over. We all can work together.
Worldwide? What is nothing mystic about the land that you see?
I mean, I think New Mexico is a wonderful place to live. Actually, that's another point, is that, I could move because, like I was saying, I could do this science almost anywhere in the world, but I want to stay in New Mexico because it's beautiful and it's a great place to live, and I have good friends, and it's just so.
One, dark matter have something to do with quantics?
Have to do with what?
With quantum physics?
With quantum? Oh, absolutely. Yeah, the best theory is that dark matter is a fundamental particle, and so if you're going to talk about, what kind of particle it is and how it interacts with other particles, you have to use quantum physics to do that. So yeah.
Okay. Thank you.
Oh, you're welcome.
What I'd like to see here is what's called general relativity. Maybe place Albert Einstein created this theory in the early 1900s. Mass or energy tells that space-time fabric. And in the space-time fabric, there's mass and energy.
What is your name and your grade? Like, do you have a PhD or what did you study?
Yeah, me llamo Andrea Albert. And yes, I have a PhD in physics, and my bachelor's is in astrophysics. But so yeah, so I have bachelor's, master's, PhD. I did all the school. Yeah.
And this is Andre Albert, your name? Albert, like ALBERT?
You got it. Yeah, ALBERT.
From here, it can be the start of a transformative change in how we think about our relationship product from today, the land, and everything.
Hello.
Any book or anything that we can read from you, or we can watch?
Oh, from me?
Yeah.
Yes. If you want to if you want to listen to me go on for an hour about dark matter, there is a lecture I gave called Cosmic Clue. And I gave it at Stanford University at SLAC, actually. So yeah, Cosmic Clue, the Dark Matter Mystery by Dr. Andrea Albert. That's me.
Cosmic Clue.
Clue, yeah, CLUE.
Great.
Yeah,
Great, thank you. And I do have a question as well. Well, I've heard that, for example, with atomic bombs and all of that, it happens with a chain reaction with the atoms, I think.
Yep.
When they like combine with a lot of energy. But what I'm wondering is what does make them stop? Because I've heard that it's like a chain reaction and it's like a huge amount of energy. What does make them stop?
So eventually, because it explodes, right? And so everything's going to get far away from each other, right? Because it's a chain reaction, but it's only like, right? Because you make a neutron, the neutrons then hit, and they make more neutrons, but eventually everything's gonna become so far away from each other that they don't hit each other anymore. So that's what makes it stop, is that it doesn't just stay contained in a small area. It gets bigger, and as it gets bigger, the atoms get further away from each other, and they just stop reacting. Also, you do run out of material, but yeah.
Great. All right. And I have another question that it has nothing to do with the last one.
No problem.
I I've heard that if you travel like I don't know how much million years in the space and you go back and see the Earth, you will be able to see like the start of the human race because of the time that is taking like for to travel. Is there any way that we can like make time machine with that?
The way that time dilation works, you can go forward in time, but you can't go back in time. And so we have like this thing called time dilation, where, like you were saying, if you travel, the idea is the faster that you move, the slower you move through time. So if you're moving through space really fast, like at the speed of light, then or close to the speed of light, then you're going to experience time ticking at a different rate than people who are not moving. And so you get this thing like the twin paradox, where you could have two twins on Earth, and one's an astronaut, and they travel close to the speed of light and then come back to Earth. And since they were traveling so fast, they didn't experience as much time because they were moving slower through time. So the astronaut would come back and be younger than the twin that stayed on Earth and didn't travel close to the speed of light. So anyway, this is a thing called time dilation. It comes out of special relativity. It's a theory by Einstein, and it is a thing. We have measured it and proven it. It's really weird, but yeah. So you can imagine, that the guy that didn't age as much. It's almost like he was going forward in time when he got back to Earth because his brother was older.
Oh, that's great.
Yeah.
So I don't know if you have seen that movie, but Interstellar is a real thing.
Yeah, right. Because they go on the planet and the time is different, and that is actually through something called general relativity. It's because the gravity is different on the planet versus in the orbit. But yep, time dilation, that's totally a thing.
Oh, that's amazing.
Yeah,
Thank you a lot for that. Oh, thank you. I really appreciate your answering your questions.
Oh, no problem. Good question.
Thanks.
Okay, bye.
Bye.
Astrologic results. He still understand the deep connections between science and science and art. Science asks questions, and astrology asks why questions. For example, why is there a universe instead of nothing?
So small that it has the energy to destroy the universe.
Not the universe, but
it's also the other with balance. It's quite evidently
Is it a measurement? Is it like, because right answer? It's not.
You want to dance a little bit?
Yeah, go for it. Oh, you want me to dance? Sorry. Yes. Here. There you go.
You can dance.
I got this one.
This is also sounds about.
And then my third dance is this one. Yes, the chicken dance. That's all I got.
Those are moves.
Good job, Avatar.
Hey, Andrea,
Hey.
we were wondering when the universe expands, what feels like the space in between?
Space, yeah.
Just more space.
Yeah, and so It's an interesting question because it's like, right, it's not just that the stars are getting further apart, but you can imagine, the stars are on top of this thing called space-time, right? And so it's kind of like imagine a balloon, right? And you take a marker and make 2 dots on the balloon, and then you start to blow the balloon up, right? And so the dots get further apart, and so then that brings back the question is, okay, well, what's in between the dots? But it's still just the balloon. The balloon itself is getting bigger and pushed apart. So like space-time itself is expanding, and so it's not really that something gets added, it just gets stretched. I don't know.
Is it ever gonna like rip off?
That's a good question. As far as we know, it's just gonna keep on expanding until everything is infinitely far apart and it's cold and it's lonely. That's yeah. So I don't think it's gonna rip. I haven't, but yeah, you never know. Never say never.
Yeah, but like if it's like expanding all the time, it's like equally expanding, which will mean that we will not notice it really, or like.
Well, we do notice it, and I mean, I guess like in our lifetime we won't notice it, but when we look at like galaxies because okay, so this is actually a cool thing, and you probably know this, but right, because of the speed of light is nothing goes faster than that, and so when you're looking at a galaxy, you're actually looking at light that left that galaxy in the past, right? So you're looking back in time. So you can look at these galaxies, from really far away, so really far back in time, and you can see what the expansion between them was, like what the expansion rate was. And so that's how we know that the universe is actually expanding faster today than it was a billion years ago, because the galaxies a billion years ago, because we're looking at them, they aren't moving away from each other as fast as galaxies are moving away from each other today, which is really interesting. And so it is something that we can see by looking at really far away objects, but it won't have any like real. It's not going to kill you.
Okay.
Yeah, so it's basically not expanding like equally. Then it's just like accelerating, like
exactly. Yeah, the expansion of the universe accelerating. Exactly. Yeah.
Okay.
Why doesn't we expand with the universe?
Oh, I guess because the expansion of the universe happens on such a really big length scale. I would say that we probably are expanding a little bit. It's just so small that we don't notice.
Okay.
Gets bigger every day.
If the universe is expanding, so we'll reach a point where we'll not be able in maybe some quadrillion years or something to see some parts of the universe because the light will never be able to reach to us, right?
That's right, yeah.
How do we know that didn't happen earlier? So the universe is actually much, much bigger than we will ever realize.
So one of the thing about the universe, right? Again, we come back to the finite speed of light. We can only see what we call our observable universe, right? So if something is, so the universe is only 13.5 or whatever billion years old. And so if there is a star or something that is 14 billion light years away, its light hasn't had enough time to reach us. And so we can only see, like 13.5 billion light years away from us. And so our observable universe gets bigger and bigger and bigger every second, right, as time marches on. And so, so far, because you can ask the question, like, okay, the universe is expanding, but what's it expanding into, right? Or something like that. And we only know about our observable universe, and so there is universe outside of our observable universe, probably. We just haven't gotten that light yet, so we don't know. Anyway, sorry, that was a bit of a rant.
there a relation between the expansion of the universe and the dark matter? Like, for example, that particle that we cannot see or something, as we're expanding, like maybe the black matter is starting to be less in some way or something like that. Like we're like expanding in that void of like dark matter, something like that.
Yeah, the interesting thing, so like dark matter and dark energy, we don't really know if there's really a deep connection between the two. We just call them both dark because they don't have light. But it's interesting because like, yeah, dark matter has gravity and dark energy doesn't. So dark matter is pulling things together and dark energy is pushing things apart. So you can kind of think of them as opposites-ish in that way. Seems like dark energy is winning because, like we were just saying, the expansion of the universe is accelerating, so it's getting faster and faster. I don't know if that helps. Those are my thoughts.
Yeah.
Okay.
It's thank you.
You're welcome.
Thank you.
Hola.
Hi.
Hello. Hi. Thank you very much for being in this event.
You're welcome.
I am from the staff the
Planetarium.
No, Noche de las Estrellas. Yes, soy comité de Noche de las Estrellas local. Sociedad Astronómica Guadalajara.
She's from the committee of the Starry Night or Night of Stars. From the astronomy.
Sociedad Astronómica Guadalajara.
Yeah, from the Guadalajara Astronomy Society.
Oh, cool. Okay. Great.
Sí.
Welcome.
Exactly. Thank you. Agradecer que estás aquí y qué opinas de el enlace entre aficionados y profesionales de la astronomía. ¿Pueden o no trabajar juntos?
What do you think about the connections or like the links between working with professionals and
amateurs,
newbies, and of astronomy? Can they work together?
Yeah, I mean, astronomy is just so important, and we all have really important roles to play. Like, I do research, but my research is, in my opinion, meaningless unless it's shared with people, and that's what you guys do. Bring the science to, to everybody. I don't know if that answered. But.
Do you mean kind of like what Agnes is doing, like
yeah, exactly.
Of the science, yeah, right?
Right.
Okay. Básicamente dice que sí pueden, o sea, sí pueden trabajar juntos y este proyecto es un ejemplo de ello, porque personas que se juntan aquí y están creando algo.
Thank you very much.
You're welcome. No, thank you.
Thank you. Bueno.